So let's start, right? With the basic ideas over here about positive and negative charges, right? If you recall, basically, what is a positive charge? Okay. So what is a positive charge? We show positive charge with this, right? And negative charge is basically this, right? Right. So we have two types of charges here, right? So the charges types are as follows. So we have two types of charges. That is static, and the other one is basically mobile, right? Can anyone share me the difference between static and mobile charges? What are static charges? What does term static means? Literally, as in the meaning.
They're not moving or like in. Huh.
Hmm. Good, right? Static means that they are not moving, right? They are immobile, right? So the charges which do not move are basically called static charges, right? So we're starting slowly. We're building foundations about charges. We will learn about some example which you physically experience in your real life, and then we see moving towards your mobile charges here. That is basically charges that move, right? Okay. So let me just go through the content here, what is written over here. So when a strip of polythene is rubbed and a cloth with a cloth, it becomes charged, right? If it hangs up, another rubbed polythene strip is brought near, repulsion occurs. Okay. Attraction occurs when the basically strip of cellulose acetate is brought near here, right? So have you experienced this? Have you played in your school? Okay, let's say you had a scale, right? You had a scale, right? And you rub that scale on your, let's say, forehead, okay? And you basically try to pick up some pencil sharp material, right? Sharp, the waste from the sharpener. So try to pick it up. Okay, they might stuck on your scale, right? If anyone has done this in your school times, okay, in the past or currently, give me a thumbs up. Okay, Maeve has done that. Vardha has done that. ओके मशाल ने भी किया है एक्सपेरिमेंट ठीक है आई बिलीव हमजा ने नहीं किया होगा ठीक है सो दीज आर कॉल्ड स्टैटिक चार्जेस राइट सो व्हेन यू रब इट ऑन योर हेड so the charges basically are transferred from your hairs to the scale right so the scale becomes basically charged right so when the remains of your sharpener ठीक है are basically brought near the scale so this basically causes since this is neutral right and this is charged let's say negatively charged so this basically causes this particular sharpener waste material to become charged, and this causes attraction over here, right? So these are basically some examples here. So let's see कि what is shown over here. So you have a polythene here. Polythene क्या होता है हमारे पास? It's plastic, right? So a plastic scale here, right? And you rub this on your forehead, let's say. So what happens? This basically becomes positively charged, right? And similarly, if you have another polythene strip over here, this is also positively charged, right? Since they both are of similar charge, and we have seen that we're not seen that basically. So let's analyze this case. Basically, the like charges are going to basically be repelling here, right? So if we have a positive charge, if you have positive charge brought near together. So they're going to have basically force of repulsion. So now you can find some similarity between magnetism and electricity, right? So I would be asking questions in between, so pay attention, right? So make sure that you know the concepts of the last chapter pretty well, right? So this is one of the experiment which basically tells us okay, if we have positive charges brought up together, they're going to cause repulsion, right? So this is the summary here, so which you should know about electrical charges. Let's say we have two cases, right? We have cases A. Let me just make it a straight line, not a straight line. Let's say you have case A, right? In which you have, let's say, two positive charges brought together or two negative charges brought together. Please ask questions, okay? Because this chapter is very important. So if you have any queries that basically jumbles up together for the next chapter also, this will give you some issues, right? So try to clear out the doubts in this chapter, right? As much as you can. Now we have case B, in which we have basically opposite charges brought together, right? We have, let's say, positive, negative here, and then we have, let's say, a negative, positive here, right? So, can anyone tell me in case A, would the forces between these two charges would be attractive or repulsive? Hmm. In case A, I want everyone to just quickly raise a hand and participate, right? I know कि सबका रोजा है. Can just give me a one word answer, right? Yes, Varda.
Sir, repulsive.
Ha. So this is again we can just make connection with the last chapter, right? So the same charges are going to repel, right? They're going to repel each other. So we're going to have a force in opposite direction, right? A force or repulsive, right? If the charges are opposite, they're unlike charges, so they're going to have attraction between each other, right? We'll see that in a while, by seeing electric fields, how is it true, right? We have seen that in magnetism, by the magnetic field lines, why there was attractive or repulsive forces. If you have missed the last lecture, please watch the recordings in which we basically learned how to we basically define the forces depending upon their field lines, right? So yeah, this is a summary over here. So the force between electric charges decreases as the separation increases over here, right? So let's say if I again take these two positive charges far away from each other, there would be a repulsive force, but of smaller magnitude, right? Again, okay, so distance also matters here. So if they're closer together, the force is going to be very obvious over here, right? So let's see the summary here. What is the summary here? So positive charges repel positive charges, but positive charges attract negative charges, right? Negative charges repel negative charges, but attract positive charges. So the summary is the like charges basically repel and the unlike charges basically attract, right? So this is the summary which you should know about the charges, right? So we have two charges in your electricity chapter, that is positive, okay, and a negative charge. Okay. Okay, so now gonna basically learn some structure of atoms, right? Some a dive into the chemistry class. Let's go over there and let's see what do we have here, right? I'm going to test your concepts of I'm going to test your concepts of basically chemistry, right? Okay. So what is the center part of an atom called?
Nuclear.
Yeah. So basically this is nucleus here, right? And what are these called?
Shells.
Yeah, these are called shells, right? And in nucleus, you know that from your chemistry classes, okay, it has protons and neutrons, right? However, it has basically neutrons and protons. However, the shells only contain basically electrons, right? We show like this cross, and across here, cross here, cross here, cross here, cross here, right? So these crosses are called basically what? Electrons, right? This is the structure of an atom, right? You should know but this much about this structure in for physics. This is more than enough, right? This is the structure of an atom. Okay. So those who are taking chemistry in their O levels right now, please give me a thumbs up. Those who are taking chemistry. Okay, maybe is taking chemistry. Vardha is taking chemistry. Hamza is taking chemistry. What about Mashal? Okay, Mashal, are you here? Okay, so again, this is not so difficult. Just a concept over here. Okay, we have a structure of atom. So the center part is called the nucleus, which contains protons and neutrons. There are shells surrounding the nucleus here, which are pretty far away from the nucleus, that are called shells, and the electrons are basically orbiting in those shells over here, right? Acha ji. So since we know that neutrons are basically neutral, right? They are neutral. They have zero charge, right? Protons have positive charge, right? So overall, the nucleus is basically positive, right? So this nucleus is positively charged, right? Electron is basically what? Electron is basically negatively charged, right? So you can see that the reason of that why electrons are still together in this entire structure forever is that if the electrons are negatively charged, so there is a force of attraction between the oppositely charged nucleus, positively charged nucleus, and the electrons, right? That basically keeps it together, right? Right. So does this make sense? The structure of atom and the reason why they are together in this particular structure. If yes, give me a thumbs up. Okay, it makes sense to me for the Hamza. Okay, that's good. Okay, Mashal, I believe that you are able to hear me and you're not chilling around. Okay, okay, that's good. So yeah, so let's quickly go through the structure over here, this theory, which is just the thing which we have discussed here. Uh, the evidence is basically we can picture atom as being basically the smallest part of anything. Okay, it contains the central nucleus, which is positively charged. Okay, it contains protons and it surrounds basically surrounded by a negatively charged electron, right? So they are defining the structure of an atom, right? Charges on a proton and electron are equal and opposite. So an atom is basically electrically neutral, right? Has no net charge. The production of charges by rubbing can be explained by supposing that friction causes electrons to be transferred that from one material to another material over here. Okay. So when cellulose acetate is rubbed within a cloth over here, electrons go from acetate to the cloth, right? Leaving the acetate short of electrons positively charged. The cloth has now more electrons that basically makes it negatively charged, right? So just a small concept here. Okay. Let me just give you an example here before this. Imagine that you have helium, right? O2, and you recall, you know that how do you find number of protons and electrons for a helium atom, right? This is basically called the atomic number, right? This is called the atomic number, and this is called the mass number, right? Okay, so atomic number is basically equals to the proton number, right? So if you want to find the proton in the in a helium atom, that is equals to its atomic number. Okay, that is 2 here, right? And if you want to find the number of neutrons, okay, so in an isolate in a neutral atom, proton number is same equals to electron number, right? So it has same electron as protons, that is 2, right? Now if you want to find neutrons here, right, so that can be found as follows, that mass number is basically equals to proton plus neutrons, right? You know the mass number is 4, you know the proton number is 2, you can find the neutron number, that is simply 2, right? 4 minus 2 is 2. So that is basically just for making you guys understand ki how is the structure of an atom, right? This is helium atom here, right? So it has 2 electrons and 2 protons. Okay. So if you want to find the overall net charge, what is the net charge? कि इस पे overall charge कितनी है हमारे पास? That is going to be 2 times -1 because we have 2 electrons plus 2 times +1 because we have 2 protons in this. That is going to make a charge of 0, right? So that is why every atom, okay, every atom in its natural state is basically neutral, right? So there is some physical processes that can basically make it to a charged ion, right? And if you recall that if let's say if I show this helium positive, This means ke it is a cation, right? Cation means ke positively charged, right? These are some concepts of chemistry which are basics, right? And if I have, let's say, helium negative, that makes it a anion. That means ke it is overall negatively charged, right? These are some basic concepts which will be used just to discuss some phenomena here, right? If it makes sense, this brief summary of chemistry concepts, give me a thumbs up. If it makes sense, it makes sense to Varda. That's good. Maeve. Does it make sense? Hamza and Mashal. Okay, it makes sense to Mashal also. I believe Hamza भी रूप में है. ठीक है. That's good. So now what is happening here is basically this here. ठीक है. So this is a hydrogen atom here. ठीक है. Hydrogen atom क्या होता है हमारे पास? It's one one. It has one electron, one proton, but no neutrons. ठीक है. It is the only element which has no neutrons, right? So let's say if you rub this, right? Let's say if it loses electrons, right? Let's say not lose electrons because the element exist नहीं करेगा फिर. Let's say it gains one more electron, right? It gains one more electron from some another element, right? So by default, it should have only one electron, right? So I can now show this by H negative, right? H negative means K, it has one excess electron, right? That makes it a anion, right? Negatively charged ion, right? Which means K, it is negatively charged, right? So this is the way static charges are transferred from one material to another material, right? The thing which loses electrons becomes positively charged, that is cation, and the atom which gains, the thing which gains electrons basically becomes anion, that is negatively charged, right? So if we have charged surfaces contracting with each other, we can have forces of attraction and repulsion. Okay, that is the reason we have static charges over here, right? So now they're basically saying over here the same thing over here. Okay, so let's say आपने scale लिया, right? And this is, let's say, Hamza standing here, right? Hamza has very good hair growth. Yeah, these are Hamza hairs, right? Hamza takes a scale, right? And he rubs this on his basically forehead. Let me just draw the scale on his head. His scale is here. Okay, oh my God. Let me just take his scale here, right? He rubs the scale on his head. So what is happening here? The electrons are going to be basically be transferred from the scale to his hair, right? And this is going to basically make his hair overall negatively charged, and this to be basically be positively charged, right? So what happens here? So you have a scale that is basically positively charged, right? If you take it near, let's say, some another sharpened pencil waste over here from the sharpener. So since they are basically neutral by default, right, that is going to basically cause some charges attraction here. So it is going to basically attract this electron here, right? Let's say if I talk about, let's say example, let's say if I talk about example over here, okay, we have a outermost electron of this particular element here, that is wood, right? So that is going to be attracted towards this positively charged scale. This is going to basically lead towards attraction between these two over here, right? So it is the electron that only moves, right? So the point is, it is the only electron which can basically move. Okay, you cannot strip in proton. Okay, so protons are not transferred. Okay, protons are not transferred. It is only the electron that moves. Okay, and the thing which loses electron become positively charged, and the thing basically the material which gains electron becomes negatively charged, right? So nucleus has strong nuclear forces which does not allow the proton to escape. Okay, it is only the outermost electrons that can basically move throughout the elements over here, right? So if it makes sense till now, give me a thumbs up, because these are just basic principles of charges and how do they flow and how what is the structure of an atom over here. Okay, so we have discussed this in just a brief discussion here, right? So now we're gonna dive deeper into the physics phenomena here, right? I believe now you know, okay, हाँ sir, we have charges, What are charges? These are positive, negative charges. You know the structure. Okay, now positive like charges would repel, unlike would basically attract. Now you know okay what actually transfers between basically materials. It is only electrons that basically causes some static charges through on different materials that leads towards attraction or repulsion, right? So now we have the charge, right? So the charge is the main thing which I'm talking about throughout the lecture, right? So charge has some unit also, because if you recall your first chapter, we talk about SI unit, right? So every quantity has its unit. So what is first of all charge, right? Charge is basically just these over here, right? Protons over here or negative point charges here, electrons here, which we show, right? So so what is the assignment of charge over here? That is coulombs, right? Because Coulomb was the person who basically invented this phenomena here, who worked on electricity. This that is why this entire thing is named after coulombs here, right? And it is small symbol is capital C here. And if I want to just show a charge of one electron, okay, so it is basically 1.6 exponent minus 19 coulombs, right? That's how small the charge is, right? Let me just fix my 9 here. So one electron has a basically charge of 1.6 square minus 19 coulombs, right? So what is coulomb? Is the unit of charge, and that should basically be sufficient to describe this, right? Now we have another thing in the pipeline, that is electrons, insulators, and conductors here, right? So now we have learned K. Let me just give you an example here for just reading this content. Let's imagine you have two structures here. First of all is plastic, right? And then you have copper here. Let me draw copper first, right? There's electrons, 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 electrons. A sea of electrons, right? We have seen that in metals. And if I talk about, let's say, a piece of plastic, or let's say, okay, let's talk about plastic, right? It has atoms combined together, right? It has no free electrons, right? Let's say if I basically supply a battery here to basically cause the production of current, right? Can anyone tell me which thing, copper or plastic, would be basically allowing the current to pass through?
Copper.
Copper, right? You will basically experience there is no current flowing in this particular circuit. However, there would be current flowing in this circuit here because copper has a sea of electrons, right? We have seen that in your chapter of metals, right? It has sea of electrons, and electrons are the only thing which basically are actually moving here, right? So electrons basically move around the circuit, which lead towards the flow of current, right? So in plastic, we don't have free electrons here, right? So electrons are basically completely tightly packed inside the atoms here. So we don't have delocalized electrons, which can actually move, right? We don't have these electrons here. So if the charges cannot move inside an element here, so we cannot have good conduction of electricity. Hence, we cannot have current flowing through that particular material here, right? So that is the type of which is going to be studied over here. So these types of basically material are called insulators, right? You might have seen plastic, right? In your switches. Let's say if you have a switchboard in your house, you might be seeing plastic is covering it, right? Because it does not allow the electricity to basically lead towards the person who is touching it, right? So they are used for safety over here, take care. And the wires, which are basically actually connecting different light lamps with your boards, they're containing copper coils, right? So these are called conductors here, right? So they can allow the current to pass through it, right? So these are the things which we'll be studying over here. So let's quickly recall by just keeping in mind of what we had discussed till now, right? So in insulator, all electrons are bound firmly to their atom. Okay? In conductor, some electrons can move freely. Okay? So insulator can be charged by rubbing because the charge produced cannot move where the rubbing occurs. ठीक है? Therefore, the charge is static over here, right? Again, imagine a scale, a plastic scale. हमने जो पढ़ा था. You can charge it temporarily using friction from your hair, right? But the charge would not move. ठीक है? They would be stick over here, right? Right? It won't be moving throughout the scale, right? So it can store static charges for a while, right? So this is very important here. So conductor will basically become charged only if it is held with an insulating handle here, right? Otherwise, electrons basically are transferred between the conductor and the ground via the person's body here, right? Up, what is happening here? What are they saying in this particular point are very important. ठीक है? ये देखें जरा आप. Let's say you are holding a wire, ठीक है? And this is Earth, and you all know that Earth is a ground, right? Earth is ground. You might have seen some wires from your house also that is leading towards earthing, right? And earth is a voltage of 0 volts, right? The voltage of earth is 0 volts. So let's say you basically are holding a wire, ठीक है, that has a continuous flow of charges, ठीक है. It is connected to a battery here, right? So हो क्या रहा है यहाँ पे कि it is basically allowing the current to flow, right? So if you basically touch this particular wire, the current will flow through your body to earth over here, right? Because your earth is at a ground voltage that is at 0 volts. So the current instead of moving here, it will move through your body, ठीक है, and basically will electrocute you. ठीक है. That is why we have plastic. We have basically safety handles. So sometimes people wear gloves, right? They wear gloves when they're operating with power lines, ठीक है, so on and so forth, so that they do not get basically shocked over here, right? So this is the reason over here. And good insulators basically includes plastic, polythene, cellulose acetate, perspex, and nylon, right? So all metals and carbon are good conductors of electricity. So all metals which you know in your head, silver, aluminum, copper, okay, and gold. So they are all good conductors of electricity and they would allow the electricity to pass through it. Okay. Hmm. So there you also have some material which are basically poor conductors and poor insulators. So you can search about these names. Okay. So I will give you basically an assignment over here. Okay. Just a homework question here. Okay. Search about this example. Right? Let's find me one atom over here which suit this definition over here, which is neither an insulator nor a conductor over here, right? Okay, search about this. So if it is clear till now, give me a thumbs up quickly. Now I'm gonna start a very interesting phenomenon which is going to be linking humanism also. Okay. Okay, makes sense to everyone. That's good. That's really good. Okay. Achari. So before starting, okay, you have learned about magnetic fields, okay, in the last lecture. So can anyone share the rough idea about electric fields? What are electric fields? Hmm.
Or an area where a charge is exerting a force, a positive or a negative force.
Mm-hmm. Good. ठीक है. That's good. Right? So let me just draw a scenario for you guys. ठीक है? फिर देखते हैं क्या होता है. So let's say you have a source charge. Right? You have a source charge here. Right? Let's say if you put a test charge here. ठीक है? A test charge means कि you're going to test कि if there is any force that is exerted on this particular charge or not, right? So you would experience K when as soon as it is placed over here, it's going to basically have a force of repulsive force in this direction, right? ठीक है? So you can compare कि source charge has a huge charge as compared to test charge, right? So source charge would not be moving a lot as compared to test charge, ठीक है? So why is that? ठीक है? Why is this particular scenario true? कि when you place a test charge around this particular source charge, it experienced a repulsive force, right? Because we have electric fields here, right? If you draw the electric field of this source charge, it would be this, right? Would be this, would be this. to be this, right? Perpendicularly outwards. ठीक है? Right? So this is the electric field of this particular source charge over here. So if you put a charge within the electric field of another charge over here, and if the test charge experiences any force over here, right? So this is basically the effect of its electric fields, right? So electric field हमारे पास source charge here. So what is electric field? Electric field is a region, ठीक है, around a charge where another charge if placed basically experiences a force of attraction or repulsion here, right? This is the summary over here, which we'll study over here, right? So the region of space where the electric charge experiences a force due to the other charge is called an electric field, right? So this is the demonstration over here of the circuitry, right? So if the electric force felt by a charge is the same everywhere in a region, the field is called uniform, right? Up, let's say if you place this charge here, this test charge here, right? Let's say here, okay? Let me name it Q2. So it would experience a huge force, okay, because it is now closer together, closer with this particular source charge as compared to this, right? But the region, but we also have a type of basically field called that is called uniform, okay? So this sort of field is called non-uniform electric field, right? Because your force is varying depending upon the position, the separation between the two charges, right? This is called non-uniform field here, right? Now we have also another example for uniform field over here, right? So what is the example over here? Let me just take you here. This is a uniform electric field here, right? Okay, you have a positive plate. Okay, you have two parallel plates here. One is positively charged, right? And the other one is basically, let's say, negatively charged here, right? So you have a set of lines which are basically parallel to each other, and they have the same distance between each other, right? Same distance. Okay, this is also D, this is D. So this is sort of an example of what? Uniform electric field, right? Let's say you place the test charge here or here or here or here, right? Or here. It will basically be experiencing the same force, right? Throughout the electric field here. So that is why it is called a uniform electric field, right? Right? I hope it makes sense. If it makes sense, give me a thumbs up quickly. अच्छा जी. So we basically learned that we have now two types of electric fields here, that is uniform and non-uniform fields. ठीक है. So direction of electric field is very important. ठीक है. अब डायरेक्शन कैसे हम डिटरमाइन करते हैं? We basically learned in magnetism के magnetic field line start from north and goes towards south, right? So let's learn this for electric fields, right? So if we have a positive charge, ठीक है, if we have a positive charge, the electric field lines are going to go out towards from it. ठीक है, perpendicular from here. ठीक है, perpendicular from here. ठीक है, and you have to basically make at least 6 set of lines, right? So this is the electric field rule. Okay, it goes out. It basically source out from the positive source, right? And if you basically just copy this for a negative charge, is going to be sinking towards n, right? Okay, duplicate slide. I'm going to now just do some magic here, right? So for negative charge, the arrow are just flipped. Okay, so it goes from negative, positive to negative, right? This is the structure of electric fields here, right? So now let me just draw example for you guys to understand, right? So this is an example. Electric field around the charge positive sphere goes out. It emerges out from positive charge. Okay. Around a point charge. So basically, you can imagine that you have a center here, right? These all field lines are going to cross the center here, right? Okay. So we assume that the charge is concentrated at the center of the sphere, right? So these field lines are basically just sort of replicating that particular process here. You have a center around a sphere where the charge is entirely centered, and this particular field line is basically generated outward from the positive charge, right? So now let me just draw an example here. How do we draw electric field lines for two positively, or let's say a positive and a negative charge, right? So it's going to be going like this, okay? Going towards this like this, okay? We can now find some relation, some similarity between magnetism and electric fields, okay? This that is the reason they are getting combined together, right? So this can be drawn like this. Is going out, is going out, and this is coming in, right? So that's how we will draw the electric field of a positive and a negative one. If we have two positive charges, they're going to basically be repelling each other, right? So now you can see the reason of attraction between positive and negative charges, right? So this is basically causing the electric field of the positive charge to be sinking, to be going in towards the negative charge. That is the reason the opposite charge is basically attract, right? Because there is a region which is basically causing the force of attraction between these two oppositely charged ions here, right? So if it makes sense till now, give me a thumbs up. Then we'll be moving towards mobile charges here, that is current, right? It makes sense to Mema, Varda, okay, that's good, right? Now we have talked about all static charges. कि static charges होती हैं, how do we draw them, how do we represent them, ठीक है? How do we draw field lines for them, ठीक है? Now we have current, right? Now we're starting basically what? The mobile charges, right? Now the charges are flowing, right? Now this is mobile charges, right? So effects of current. First of all, let's see the effects of current here. So what do you have here? You have a battery here, right? And these are wires, right? These are wires here, right? The brown ones are wires. So these are connecting basically plotting compass here. And this is basically connecting a lamp here. The lamp is glowing, right? And this is basically going towards electrolytic setup over here, right? So we have electrolysis getting processed here, right? And this is going toward back to the negative plate, right? So this is positive, this is negative here, right? So you can see that over here, the compass basically works on magnetism, right? It works on magnetism, right? And the lamp works on electrical phenomena, okay? It has a filament which glows, okay? It has a filament which glows, and this is a chemistry concept in which basically we are having basically the charge is flowing from cathode to anode, right? Cathode to anode, right? So let's see what effects over here is happening here. So my current is flowing, right? The current is flowing throughout the wires. Current flows through here, current flows through here, and then reaches back to the circuit here, right? Throughout the circuit, we have current flowing throughout the different phenomena. So in between, we had different setups here. We have lamps, we have compasses, we have electricity setup over here, right? So let's see what effect does current have on these three sort of fields here, right? So on the lamp, obviously when the lamp glows, the current is flowing through the wire. When the current flows through the wire, it makes the filament lamp to be hot, right? Why? Because there is some resistance which we will see कैसा होता है हमारे पास. So just imagine if you have a wire, ठीक है? If you have a wire and the current flows through this, it will get heated up, right? Have you touched a filament lamp? Have you touched any bulb in your life? If yes, give me a reason, thumbs up, चलें. Have you touched any bulb? Let's say white LED bulb. Anyone? If yes, thumbs up. Yeah, you might have felt that it is basically hot, right? So it has a filament inside it or an LED, okay, which basically when it glows, it basically produces heat energy, right? So that is the effect of current flowing through a lamp or a bulb, right? And when the current passes through a compass, it is going to cause deflection over here, right? Right? We will see that is basically a reason of electromagnetism, right? You don't need to learn this in detail. Just imagine, just learn K if you have a compass, if you have a wire carrying conductor, okay, that is current carrying current I. If you have a compass here, right? So this compass will basically have deflection, okay? This needle will basically will go either in this direction or in this direction when the current starts to flow, right? And in chemical part over here, that is the part where you have electrolysis. Obviously, you will see bubbles over there, right? Bubbles of gas. Because when electricity when electricity take place, you have either hydrogen or oxygen gas produced at the anode. Okay, where you basically have that is produced as gas and goes out of the setup and produces bubbles, right? So this is just a brief discussion over here. Okay, this is current what we are talking about over here. It is a thing which flows, right? It is a thing which flows throughout the circuit, right? And it has its some unit. It has a SI unit that is called ampere, right? So why ampere? Again, ampere was the person who discovered this phenomena here. Okay. So what is current? First of all, let's start discussing it. Let me just first of all draw a circuit here. So I'm just drawing a simple circuit. Okay. A simple. This is going to be a first ever circuit, right? A simple electric circuit. Okay. Make sure to ask question if you're lost. Okay. So इसके अंदर we have a battery, right? And then we have a resistor, and then we have a lamp, right? Let's say this is a 10-volt battery. This is a positive terminal of the battery. This is a negative terminal. This is called the resistor. This is called the lamp, right? And lamp is glowing. Okay, the lamp is glowing over here, and the current is flowing from positive to negative, right? This is current I, I, right? It's flowing in this direction here, right? So in this we have the three setup here. We have a battery here. This is called a battery. We learn about this in detail. No worries. Okay, just give me a brief summary here. This is called a resistor. We will learn what is a resistor in a while. Okay, so don't be confused. Okay, and this is basically called the lamp. Right. This is called the lamp. Right. So you can see that there is some phenomena, something moving around the circuit over here, right? So don't just stick to the complexities here. Okay, nature is complex. Just try to dive deeper into it over here, right? Let's just go back to this to the atom here, right? We have an atom here which has electrons, right? So if you have a let's say conductor here, what thing can get out? Electrons, right? So electrons are the thing which can move. Okay, these things can move, right? So actually the charge is, right? The charge is moving around the circuit, right? The charge is, right? Right? And the charges move around the circuit in certain amount of time. That is basically creating a phenomenon that is called current, right? Imagine this is a point A, this is point B in a circuit, right? ये हमारे पास चार्ज है हमारे पास Q, ठीक है? And the Q basically went from A to B, ठीक है? In an amount of time delta T, right? So if I want to find its ratio, that is going to be my current, right? So current is just the rate of flow of charges. Okay, how fast the charges are moving around the circuit is going to be my current. If it makes sense, give me a thumbs up. Okay, what is current? Okay, it makes sense to everyone. That's good, right? So just again, just try to recall the basics, right? So it's all basic over here, right? So what is current? It's just basically, if I want to define current in a single sentence, it is the rate of flow of charges. Okay, it is the rate of flow of charges, right? If I want to write down this formula, so the formula for current is basically uh, Q upon T. right? You can just write capital Q since it is used by a book. It's capital Q over T, right? So this is the formula for charges, and where Q is basically charge, right? It is measured in coulombs, and T is your time. It is measured in seconds, right? And I is current, right? The SI unit for current is basically what? It's amperes, right? If you recall your first chapter, we learned about base quantities, right? We had seven base quantities, and out of those, ampere current was also one of them. Okay, it has ampere, right? It is ampere. It is measures in small capital, sorry, capital A over here, right? So the unit of current is amperes. 1 milliampere is this. Milli is the prefix which we have learned, right? And current is measured by ammeter here, which we will learn in a while. Ammeter क्या होता है, ठीक है? So the definition which we should basically you should learn for your exams is as follows: the electric current is the charge passing per point, passing a point per unit time over here. So it's measured in this formula here, right? Where Q is the charge, okay, T is the time, right? Achari. So we have multiple units for current here also. Okay, let's see that how. So just recall this formula of current. The current is basically what? Its charge is upon time, right? The charges are measured in coulombs, right? And the time is measured in seconds, right? So we can also have one possibility of your unit of current is basically it's coulomb per second, right? Right? But the standard, the person who discovered this was amperes. So we also have representation of amperes in its base quantities. That is that 1 ampere is basically 1 coulomb per 1 second, right? If there's a question in your exam K, define 1 ampere, right? Define 1 ampere. How would you define 1 ampere? Yes, anyone. What is 1 ampere? Just see the formula and let me know. So it's very simple, right? So it is the amount of current. It is the amount of current flowing when 1 coulomb of charge move past the point in 1 second, right? That is how defined 1 ampere here, right? So this is just a definition here for basically 1 ampere, right? So now if you want to find the relation of charge also, okay, because if you recall in a circuit, let's say if you have point A to B, okay, it is the charge which is moving, right? Right? It is the charge which is moving through the circuit, okay. So if I recall the formula of current, the current is basically rate of flow of charges, right? I can also find the relation of charges, okay. That is going to be the Q is basically current times time, right? So the charge flowing through the circuit is basically the amount of current flowing times the time it takes to flow, right? So the unit of charge is basically coulomb and is defined in terms of ampere. So 1 coulomb is the charge passing any point in a circuit when a steady current of 1 ampere flows for 1 second. That is 1 coulomb is 1 ampere second, right? Just see this formula. Just see okay, when you have 1 coulomb is going to be 1 ampere times 1 second. That is 1 coulomb is equals to 1 ampere second, right? I hope it makes sense. So now this is the definition of ampere, right? So ampere is the current given by coulomb per second, right? That which we have discussed here. Okay. So these are all very important terms which comes in your MCQs, okay, theory. So don't just miss it out. Okay. These are very basic definitions, not so difficult. Okay. So if you go step by step, it should make sense. So if it is clear till now, give me a thumbs up quickly. Then we'll do a question and then end the class. Okay, it makes sense to Mema, Varda, okay, Mashal. That's good, right? So now we have a last question here, which we will cover, and then we'll basically be ending the lecture. You will have a recorded lecture, hopefully by midnight, okay, that you have to watch before the next session, right? सो टॉपिकल पास पेपर आपकी आ जाएगी, अपलोड होने वाली है फ्रॉम द टीए। तो you have also your mock in the next week. I'll be announcing the timing soon. ठीक है, I will announce the poll for selecting the time slot. You will have P1 on Saturday, P2 on Sunday. ठीक है। जल्दी से solve this question. You have 3 minutes to solve the question. I want the answers to be shared to me over voice or through chat. When you're done, give me a raise of hand quickly. ठीक है। Okay, so I can see two people are done here. I'm waiting for the others. I'm gonna give you 1 more minute. ठीक है। Then I will start doing the question. Okay, I can see. I guess that's enough. Baki can verify the answers from here. So what do you have here? You have a charge of, let me just give you an example here. You have a circuit here. You have a resistor here. ठीक है। Let's say this is point A, this is point B, right? And from point A to B, the charge which is basically flowing is 2 coulomb, right? ठीक है। And the time it takes to pass is 5 seconds, right? If I ask K Mashal, let's say, find me the current flowing through the circuit. Mashal should know the formula, right? First of all, you should write down okay, what is given to you, right? What is given to you over here is charge, that is 2 coulomb, and you have the time in 5 seconds. You want to find what? You want to find the current, right? So current ka formula is basically it's the rate of flow of charges. It give you 1 mark. Now put in the values here. Current is going to be basically 2.5, that is 0.4 ampere, right? Right? This is the current flow through a circuit. ठीक है। So if your answer matches, give me a thumbs up. Okay, Mehma's answer matches. Hamza's answer matches. Vardha answer matches. That's good. ठीक है, simple, right? So it's going to get interesting soon, right? So if your basics are strong, the next part is going to be easy, right? Now you have 2 minutes for this question. Now you have, what do you have here? So what is given to you here is you have a current that is 3 amperes, right? You have a time it takes to flow, that is 10 seconds. You want to find the charge that is flowing, okay? Again, that is very simple, right? So first of all, you should write down the formula here. The current is basically the rate of flow of charges. You can make Q subject over here. The Q is going to be basically be current times time. Just put it the value here. That is going to be 3 times 10. So the charge that is flowing through the circuit for 10 seconds is basically 30 coulombs. Okay, this is your answer here. Okay, now the important part is going to start from here. That is conventional current here, right? Can I even explain or let's say answer the question? Let's say if we have this circuit here, this is a resistor, this is a lamp, and the lamp is basically glowing here. Let me make a correct battery so that you can relate with the content. So it's a battery here, right? This is positive, this is negative here. Can anyone basically tell me the direction of current? Okay, does it flow like this? Positive, negative, or it flows from negative to positive? Raise a hand and answer quickly. I want a quick comment here. Hmm. Current flows from positive to negative or negative to positive with what you have learned in your school or your through your self study. चलिए बताएं. I want a quick answer. Give me a guess. I want to see. Yes, Mashal.
Positive to negative.
Positive, negative. And the name for this current is given as, what is the name that we call it?
Convention.
Conve-
conventional current.
yeah, conventional current, right? Acha ji. So once upon a time, when the electron was not discovered, right? So it was a time when electrons were not discovered, right? Electrons were not discovered, right? So this phenomena of electricity was already discovered, right? So they had to basically think about, okay, yeah, actually what is moving around the circuit. So we didn't have idea of about the structure of atom very good, okay? So we had a rough idea, okay, we have a pudding, sort of a pudding, right? Of a this is atom over here, and we used to imagine that this was proton over here, right? ठीक है, and this was a gold foil experiment, Rutherford gold foil experiment here, which was done, if you recall this. You will do this in your nuclear physics, ठीक है. So through this we discovered nucleus here, right? So electrons were not there, so the only charged particle which we knew was proton, right? So that is why the scientists, the physicists who basically discovered this phenomena, so they assume कि यार a positive charge should move over here, so the current should move in this direction, right? I, right? So this particular type of current is called as conventional current, right? But based upon this, we discovered all the laws. We discovered the Ohm's law, okay, and which basically works out every formula in your electricity, which contains this direction of electric current, right? But actually, what is happening here? Actually, होता क्या है, ठीक है? If you recall the structure of atom, right? We have a nucleus and then we have shells, right? And in shells we have electrons, right? These electrons basically are the thing which move, okay? Because protons can the nucleus cannot escape, right? Because we have weak nuclear forces inside the nucleus, which are very strong, right? So actually, hota hai kya? Actually, the electrons are moving, right? Like this. Okay. So the electrons are moving like this, right? So after discovery of electrons, everyone was shocked, right? Because we have because at that time the physics laws were completed for electricity. We have basically established motor also. Okay, how does motor works? So everything was discovered here. So actually, the direction of current is basically this I bar, right? So I bar is the actual flow of current. So scientists then again discovered the formulas. They derived the formula again, which basically surprisingly came out to be same, right? So if you take this direction or this direction, okay, it does not basically change the formulas. So therefore, since our theory was solidified on this direction of current, that is the purple one, okay. So we basically decided to go with this conventional current flow, right? So all the physics, all the electricity laws till university, till high level physics. So basically, it uses this particular direction, right? So that is why it is called the convention. Convention means ke purana, ठीक है? It is of the old school. So if it makes sense, ke how was conventional current discovered and how was it basically tested and why is it continuing uh, to be used? If it makes sense, give me a thumbs up. ठीक है, it makes sense to Mashal. It makes sense to me. Hamza. Mama, are you here? Does it make sense? Mama. I believe Mama is not able to speak. Let me check the comments. Okay, I believe she is there. Okay, so let's basically skim this slide over here. That is what we have discussed right now. So before the electron was discovered, scientists agreed to think of current as positive charges moving around the circuit, right? From positive to negative of a battery. So this agreement still stands because if you just see a book of master or bachelor level also, they are using the same laws. Okay, I also learned the same laws too. I was surprised too. I also asked this question to my professor, right? And he answered every law of electricity, which we had derived using positive flow, is exactly the same as of negative flow, right? So only the sign is changed, right? Because current is basically vector quantity. If it is positive, this direction is going to be negative here. So we only take the magnitude here, right? What is magnitude? That is only the amount of current flowing. Okay, so therefore the all the formula still stands, right? So arrow on circuit diagram shows the direction of what we call conventional current. That is direction of in which the positive charges would flow over here, right? So in this conventional current, the purple one, they basically were assuming here the positive charges were flowing, okay, that is proton. But chemistry wise, okay, electron structure wise, that is not possible, right? So this is the difference between the two flows, which is basically considered in electricity over here, right? So electrons flow in opposite direction, we have learned, right? So this is the definition which basically appears in the exam, and you should answer this question like this. Okay, it comes off 1 mark only. Okay, so conventional current flows from positive to negative over here. Okay, and the flow of free electrons is from negative to positive here, right? So that is more than enough to just basically describe this flow. Okay. So ammeter, right? So now you know how what is current, right? You know the direction of current flow here, right? How do you measure the current of flowing thicker, right? Let's say if we have a circuit like this, okay. Let me again make batteries here. And I end up making bachelor level battery sources. This is a battery here, right? And let's say this is a resistor here, right? This is a battery of 10 volts, right? Plus, minus, and this is a resistor of let's say 10 ohms, right? And we have learned now the current flow in this direction, right? Up, let's say I want to measure the amount of current flowing, right? So what is the current flowing over here? I will basically learn some ways to derive the value using formula. But let's say if I want to derive this using experiment, right? I don't want to use the formula here. So what can I use over here? So I can use ammeter here, right? So ammeters are basically used to measure currents, right? They used to measure currents here, and it should always be placed in series, okay, with the positive terminal of the battery. So where do you place the ammeter here? Always here. Let me just show you. Always with the positive leg of the battery, like इसका symbol होता है ये, ठीक है, called an ammeter here, right? It has a symbol of this a ammeter, right? So this is the positive leg of the ammeter. This is a negative leg of ammeter over here. You can see in the diagram here, it has two wires. The one is red and the black one is black over here. So red one is always positive here, and the black one is always negative here. Okay, this is a convention which we follow in electricity throughout every color coding here, right? If it is battery, again positive is red, black is negative. Okay, if it is ammeter, positive is red, black is negative. It is voltmeter, which is basically again red is positive and black is negative here, right? So that is basically going to give you the reading of current flowing in the circuit here, right? Okay. This is the analog version over here, right? What is analog version? It has no digital display here. It has a needle, right? If I can zoom in here, it has a needle, right? It has a needle here, which basically gives you the value here, right? You can see this needle basically moves here and there. So this is analog version over here. But if you want to basically, in modern era, in current universities or let's say labs, if you go to your school lab or let's say college lab, you will see this particular meter used over here, right? Or let's say if you have an electrician in your house, which basically came to fix your, let's say, power supply, or let's say your fuse of your house, he might have this instrument with himself, right? So this is called a multimeter here, right? Right? This is called a multimeter here, right? And what does multimeter does? Multi means कि obviously it can perform more than one operation, right? इससे you can basically measure current. इससे you can measure voltage also, right? And so on and so forth, right? So it can do multiple tasks over here. And also again, since it is digital over here, it's basically shows the answers in digits here, right? It has a digital display, which is basically this, right? Okay. Achari. So now let me just show you a video for basically using that digital multimeter for measuring current and voltage, right? It would make sense. It would be interesting here, right? So let's go to YouTube over here and see how do you use this instrument practically, right?
Supply, and we are going to measure how much voltage this battery has. So for that we have connected this multimeter.
Okay, so in this video, this will basically show how to measure voltage, current, and resistance. Okay, using multimeter, right? So this is just for your ATP part over here. So I just want to also make you understand, yeah, you use it in real life, right? And how do you use it?
Students, let us see today various quantities we can measure using this multimeter. First of all, we are having DC power supply and we are going to measure how much voltage this battery has. So for that we have connected this multimeter in a proper way, and to measure the voltage of this DC battery we are going to put our indicator on 20 volt, because as we know it very well from the battery specification, battery is showing us 9 volt, and let us see what your multimeter tells. So
Basically, we have different options on multimeter, right? So यहाँ पे you can see volt here. तो यहाँ पे लोगों ने रेंज बताई हुई है कि मैक्सिमम 20 वोल्ट तक आपके पास बैटरी है तो यूज दिस ऑप्शन टू मेजर द वोल्टेज here, right? So and so on and so forth.
positive terminal of my battery is with the positive and negative terminal of my battery is with negative.
And red is positive, black is negative.
I have to connect in that way, and we can see here the display shows us 9 volt battery. So the battery measurement we have done in terms of voltage. Yes, now for current measurement.
Acha, this is called a breadboard, which basically makes circuits actually for hardware. And this you can see an LED over here, and this is a resistor here, right? So she has made a circuit like this. Okay. She basically made this circuit here. So you have a battery here, then you have a resistor, and then you have a LED here, right? So this is a circuit which she have made over here, right? So battery, resistor in series, and then LED, and then it is grounded here, right?
We have mounted a circuit components in a way that we can see the LED light which will show us glow, and as well as it shows current over here in the multimeter display.
Okay, and you can see over here, she has a battery here, and then resistor here, and then she has a LED here, and then you can see कि ये basically red wire लगी हुई है इस multimeter की, right? This multimeter is now operating in M meter mode, right? So M meter is always in series here. So this is basically the circuitry which she has made here. So she has an M meter here, right? So we will learn that in series, the order of component does not matter, right? Because in series, current will remain same. We will learn this in a while. So don't worry. So let's understand that उन्होंने ammeter, the ammeter which she is using over here, is in series. ठीक है? Yeah.
So for that we have connected fixed resistor, then LED, they are in series. Then we have connected this current meter just to see the current measurement. So I'm connecting this battery positive to resistor. Yes, now you can see LED has started giving us output light, and as well as you can see the current 3.54 milliampere current is flowing through the circuit. So this is how we can measure current, and we have chosen the appropriate range for current. Okay, so how I have chosen the range, let us see that. The maximum appropriate available for us, that is 200 milliampere. This is very high, so we are not going to consider this 10 ampere current range. So for us this 200 milliampere range is sufficient. Fine. First of all, I have connected it and I have chosen the range. First of all, we have chosen the range 200 milliampere, and you can see the display that it shows 3.8 milliampere. This is the maximum current flowing in the circuit. So we can a step go down, that is 20 milliampere. We know it very well, 3.8 milliampere will definitely show us the value in 20 milliampere. This is how we can get the precise result. So for that we have to always.
This question is important, right? You might be asked to find rating, okay? So that's how you find maximum currents also, Okay, it's just a demonstration here.
We start from higher to lower when you are interested to measure current, when you are interesting in current measurement, right? So this is the precise result. 3.77 milliampere current flows in a given circuit. Let us see the resistance measurement of a given carbon color code fixed resistor. Fine. So you can observe that the color band is
Okay, we will learn about resistors inshallah soon. So resistors are the components which basically blocks the current flow, right? So we basically do measurements. Okay, what resistor we need to place here, right? So if you want to measure the amount of resistance it basically offers, we use basically multimeters also to measure it, right?
given on the resistor: brown, black and yellow, and the last one is for tolerance.
Achha, it has color codes here. So color codes are basically shortcuts, shortcuts to learn the values. So we will learn in resistance ke what does each color code shows here. Okay. So let's say if you don't have multimeter, the manufacturer who produced the resistors here, he has placed the color code such a way that if you are from the background of electrical engineering or electricity, you can just read the color codes and get the value. Okay. So that is also one way to get the values.
So as per theoretical value, we are having 1 0 into 10 to the power 4. Now let us see. Are we getting the same value through multimeter? Let
So it's 10 kilo ohm resistor, right?
us see it now. So theoretical
That is 10,000 ohms.
value of this is 100 kilo ohm. Okay. So for
Okay, so it's sorry, 10 to power 4. So it's basically 10 and then into 4 zeros. That makes 1 lakh. Okay, so it's 100 kilo ohms.
that, once you get theoretical value, then you can easily choose the range. Here I have chosen the range 200 kilo ohm and you can see that 99 kilo ohm we
You
are
can see that it is showing 100 kilo ohm ka resistor actually tha, but you get it 99.1 and K is here, right? So measuring kilo ohms here. So there are some errors in readings also, which you basically will learn in a while. Okay, so this is just an discussion over here. Okay, how do you use multimeter here? So this video was pretty good. It covered everything, right? Which we'll cover in a while. Resistance kya hoti hai, how do you measure it, and so on and so forth, right? So let me place it here so that you can basically get an idea by just preparing this video. Okay, if it makes sense, okay, how we used multimeter, give me a thumbs up. Because inshallah, in your A levels, if you take physics, you will be using this, right? Inshallah. If it makes sense, give me a thumbs up. Okay, how did she use multimeter? Okay, it made sense to Maeve. Okay, it made sense to Masha. It's just simple operations जो हमने सीखे हैं अभी. ठीक है? That's good, right? That's good. Makes sense to everyone. So now we have interesting topic here to cover here. That is direct current and alternating current here. Can anyone explain what is direct current and what is alternating current? Because this is very important here, right? This has history, right? This has history. Nikola Tesla will come into this sort of story here, and what happened that basically we are right now working on uh, AC power supply, right? So can anyone quickly give me a summary? What sort of electricity comes to a house? Is it direct? Is it alternating? It's a very simple question here. So what electricity type comes into your house? Is it alternating? Is it direct? Yes, guess. Give me a guess. You can basically drop in a comment also if you want. Silly listen. Okay, so I guess you have no that idea. Okay, so let's start, right? So direct current is basically the current flowing in only one direction, right? Just first of all, let's just see the definition here. Then we will start to see graphs, which will make sense. So direct current means के the electrons flow in only one direction, right? ठीक है, only in one direction. ठीक है. And in alternating current, basically the direction of the flow reverses regularly, right? So let's see this. ठीक है. This is direct current here. This is DC current here. ठीक है. And this is alternating current, AC, right? Sorry, it's not alternating current. This is again DC over here. Okay, these are all DC here, right? So if you just see a graph in your mathematics class, right, you basically saw that this was positive Y, this was negative Y, right? So you can imagine that this is positive current here, right? And this is again positive current here, right? So these are both example of DC over here, right? You can see that we have again इसके अंदर two types, steady DC and varying DC, right? Again, in both of the graphs here, the current is again positive. Let's say it was positive 5 amperes here, right? And let's say this was varying, fluctuating here, but still it was in the positive side of the axis, right? So this is called example of direct current here, right? If it makes sense, give me a thumbs up. What is direct current? Okay, it makes sense to Maeve. It makes sense to Hamza. Okay. What about Mashal? Okay, that's good, right? So direct current is the current or direct voltage is the voltage that is only flowing in one direction. That is, if it should be in the positive axis here, right? ठीक है. Now let's see what is AC here, right? This is alternating current. If you can see, call it mathematics class, it is sort of a sine wave, right? Sine graph, right? This is your alternating current here. You can see again, this is positive side of the graph. This is negative side of the graph here, right? The graph is oscillating. It goes positive and it comes back in negative. It repeats, right? Just like a sine wave here, right? It repeats after one cycle. Okay? So the chapter of waves, which you have learned before, would come in handy here, right? So this is the AC current here, right? And this is the basically supply, the electricity supply which is coming into your house, right? Coming to your house. ठीक है. So इसमें basically इसका symbol ये होता है. If you want to let's say make a circuit here, so this would be circuit symbol over here. ठीक है. This is AC supply and this would be a resistor, right? So this is the AC symbol which you should learn over here, right? So this is a resistor here. So अच्छा, इसकी हिस्ट्री क्या है वो देखते हैं हम लोग इन अ व्हाइल. ठीक है. लेट फर्स्ट ऑफ ऑल डिस्कस द फ्रीक्वेंसी ऑफ एसी ग्राफ, राइट? So we have done waves, so you know, okay, how do we find this? It's pretty simple here, right? So let me draw a wave here, a sine wave here, which represents that AC current, right? This is, let's say, positive I, and this is negative I here, right? I'm going to have a wave like this, right? So let me just take the axis thoda upar, right? So that it is almost at the center, right? Okay, this is time in seconds. This is the current in amperes, right? So can anyone tell me when do we have one complete cycle here? So you can see that this one cycle sort of ends here, right? Right. So after this, the cycle repeats. It ends here, right? So the one cycle duration is basically this, right? This is one complete cycle, right? And we learned in waves. Okay, this is also basically lambda, right? Wavelength. But you don't want lambda right now in this particular sort of chapter here. We're only interested in the time it takes, right? The time it takes to complete one cycle is basically called time period, right? So this is T here. That is called time period, right? And it is measured in seconds here, right? So how do I find frequency? You all know this, okay? Frequency is basically 1 over time period, right? And the unit of frequency is hertz, right? It is measured in hertz, right? So now this is basically how you find frequency. So this will be used repeatedly in your chapters, okay, in your questions, which will basically counter in the upcoming slides and questions, right? Acha ji, now you basically want to do what? Let me just see the timing of the class. Okay. So now we'll basically touch upon the history, right? We touch upon the history of DC and AC over here. What happened, right? Was there any DC supply before, or was it AC from the start of the history of electricity, right? So what is happening before, right? Just before, let me just show you here. So basically, what is the scenario which happens right now? Okay, you have, let's say these are the transmission lines, right? Let's say these are the transmission lines here, and this is your house here, right? This is your house here, and we have the window. Oh my god. Okay. Then you have electricity supply from here, right? And it comes to your house. Okay. And this is basically all AC, right? So this is coming into your house right now. Okay. And if you can see in your house, let's say your fan, right? Your refrigerator, right? Okay. Why do you have chargers? Okay. Charger basically convert your AC to DC, right? Because your phones cannot charge on AC supply. That is why we have a charger. So charger के अंदर हमारे पास ये conversion हो रही होती है because it needs a constant 12-volt supply to charge your phones, right? And then in your fan, if you open a fan, if you have seen a fan, you might have seen it contains coils, set of coils. So these coils basically works on AC, right? Refrigerator, right? It has again a compressor, right? Compressor contains basically gas, and how does it operate? It works in already current supply, right? It needs this here, right? Any application which is in your house, motor, right? The water motor here. Motor works on AC supply, right? So basically this is the current scenario over here, which is active throughout the entire universe. But once upon a time, once upon a time, once upon a time, everything was in DC, right? Everything was in DC. You can search this. This is a true fact here, right? Everything was working on DC supply, right? पहले क्या होता था हमारे पास? We used to have only one wire. Okay? We used to have only one wire that used to connect the two basically sides of, let's say, this is the power production side. This is the power plant here, right? And this needs to basically bring your supply to your houses, right? So what used to happen here? We used to have all the applications at that time in DC, right? So, but what was the issue at that time using DC supply? That was okay, you cannot send electricity for longer distances, right? And but let's say if your house was, let's say this is USA. It's, let's say if you want to send the electricity using DC source to, let's say, Canada, because they are neighboring countries, right? So it would not be possible, right? Because why? Because of the losses here, right? So we had huge losses, right? Which basically lead towards so this will basically lead towards huge losses, and hence it was not useful. Okay, so right now you can see different countries are providing supply. Okay, so let's say Karachi is getting powered up by K Electric, right? Let's say we talk about Balochistan. Balochistan is very far away from Karachi, right? So Karachi is getting power to Balochistan also, right? So this is possible using AC supply, right? And we'll see the benefits here. What are the benefits and drawbacks here? Okay. So this is the basically the history of over here which you need to learn here. Right? Then now we have basically the final thing to cover here, that is the volts, right? the thing which basically moves your charges, right? So we have two important phenomena here, that is electromotive force and potential difference here, right? Okay. So we have electromotive force and the potential difference, right? There are two important terms here. You can imagine a circuit here, imagine a circuit here, right? And this is the battery here, and this is the resistor here, right? So it, let's say if you have a device like multimeter, आपने multimeter place करा and you measure the voltage across this resistor, right? So the battery provides electromotive force, that is called EMF, and the voltage that is lost, that is dropped across the resistor, is called the potential difference. That is very important to discover here, right? So these two definitions might seem very similar, but they are very huge difference. The battery is providing push for the electrons to move, right? It pushes the electrons to move here. And यहाँ पे क्या हो रहा था हमारे पास, यहाँ पे सारा एनर्जी लॉस हो रही होती है क्रॉस रेजिस्टर, राइट? So let's see what is EMF. ठीक है, so EMF is basically defined as electrical work done by a source in moving a charge, unit charge around a complete circuit, right? Let's say if I talk about the conventional current flow, ठीक है, let's say if I have my charge here, so if this charge moves completely throughout the circuit, ठीक है, this is 1 coulomb of charge, right? So if I move 1 coulomb of charge throughout the circuit, ठीक है, so the work required to move a unit charge through one complete cycle is called electromotive force, right? So electromotive force is work done upon charges, right? And what is potential difference here? That is very important here. So you know electromotive force क्या होती है? Potential difference is the work done, ठीक है, by unit charge passing through a component here, ठीक है? जब ये चार्ज पास करती है through this component here, this is point A, this is point B here. So the charge, the work required to move through this component for 1 coulomb of charge is called the potential difference here, ठीक है? So there are usually number of components in a circuit. We have bulb, let's say we have resistor, we have diode, we have LDR, so on and so forth. So potential difference is basically defined as the work done by unit charge of passing through a component, right? Through one component here. So you can see the definitions are very similar here, right? If you see for electromotive force, it is work done upon charges. And if you see for this voltage, it is work done upon charges, right? So this is a difference over here, कि work done on a component for potential difference. This is work done by a source, ठीक है? So इसके लिए you have to be careful here, right? So these are very similar terms, so you have to be careful here about these two definitions here. We're gonna first of all see what is the content here, and then gonna basically hear about a story of Mr. Coulomb here, right? It's a very interesting story here, right? So let's first of all go through the content here. What are they saying here? That is energy transfers and potential difference. So in an electric circuit, the electric current transfers energy from an energy store such as battery, right? And two components in the circuit which then transfers energy into the surroundings, right? So in case of a lamp, energy is transferred to the surroundings by light and heat, right? When let's see this over here, we'll see this picture in a while. Okay, let's first of all read the content here. So when each of the circuits shown in the next slide is connected up, it will be found from the ammeter readings that the current is about the same in both of them, right? However, the main slab with the potential difference 230-volt supply gives out more light and heat as compared to 12-volt lamp, right? We have the circuitry here, which basically has two power supply here, right? So it has a voltage supply of 230 volt, right? And this circuitry has a voltage supply of only 12 volts here, right? So over here, we're using a lamp which is of 100 watt, right? It's high rating power lamp over here. You can imagine a street light lamp, right? Which is used in streets over here. Then we have placed an ammeter in series. Okay, so we have a supply. The circuit is as follows. We have a AC supply. Let me draw the supply here properly. So we have an AC supply here, right? And then we have a lamp here, right? This is a schematic over here. Okay, for both the circuits. Uh, the supply, and then we have lamp, and then we also have ammeter. I forgot about the ammeter here. Let me draw the ammeter here. So we have the ammeter here, right, in series. So this is a circuitry which is used in both of the configurations here, right? So what is happening here? Current is coming about to be same, right? So both of the ammeter are basically giving you same reading. You can see that the readings are same here, right? Okay. So, however, as you can see that this circuitry has a high voltage supply. So this would give out more heat energy, right? They can produce more light since it is basically of higher power. It will be more brighter, right? As compared to the 6 watt lamp here. However, the current is same, but the brightness is differing here and the amount of heat produced by each lamp, right? You might understand this if you recall some old times in which you had yellow sort of lamps, okay, where we basically haven't discovered LED lamps, so we used to use a filament lamp, right? So you can imagine this is a filament lamp here, and this is, let's say, a small LED bulb here, right? So just imagine this, it produces a huge amount of energy, right? And plus heat also, right? So these are used in bakeries and to just keep the cookies warm, right? And this is we'll see this case why does high voltage supply has, we need to basically keep this in mind, right? What is the thing which you need to keep in mind, that if you have high voltage, right, that produces basically what? High light, right? Okay. I mean, just make keep it as brightness, glow. It's more better to use. So the glow level is basically increasing, right? So we'll see this in a while. Okay, what is basically happening here? The current is same in both of them, right? The current is constant, right? And we'll see that why does the bigger power rating lamp produces more heat energy, right? So we'll see this in a while. Okay, so this is just we are seeing the effect of potential difference here, right? Okay, if you have a high power rating, okay, you're gonna have higher potential difference across this, going to consume more voltage, right? And this basically leads towards high brightness and high basically heat production to the surroundings, right? So let's understand the story here. What happens, right? How does the circuitry works, right? So you can imagine Mr. Coulomb. Let's say Mr. Coulomb is the person who is doing all the hard work here, right? So you can imagine as Popeye, right? Have you seen the Popeye Sailor Man? I believe everyone has seen this television cartoon. This is Popeye the Sailor Man, right? So he used to basically eat Spanish, right? To get power. Over here, Mr. Coulomb basically gets the power from the battery here. Okay, the voltage battery. Let me just label it as battery here. So this Mr. Coulomb gets basically his power from the battery, right? And this is basically sort of the region we're having loss, right? So imagine a journey, right? Imagine let's say you're going on a journey in a desert, right? You're going on a journey in a desert, right? And you have some water in your hand, right? First of all, let's say you came across a lake, taking the initial journey over here. You fill your small bucket here with the water, right? And you continue to move, right? Let's say you move from point A to point. Obviously, when you're moving, you're doing work, right? Your body is consuming energy of your the body basically consuming energy from your let's say blood cells, and you need to basically intake water, right? And let's say your water bucket is now empty, right? So imagine this Mr. Kuram is doing the same thing over here, right? This bucket, the basic bag which he's basically carrying over here, is the amount of electrical energy, right? Right? He fills the electrical energy from the battery here, right? So first of all, let's say this is the point A and this is point B here, right? So Mr. Coulomb starts his journey, right? And you can see that as soon as he reaches, let's say, point C, his bag becomes slightly lesser, right? Slightly, let's say, thinner as compared to this. Why? Because in reality, these are wires, right? Okay? These are wires and they're made up of metal, right? Metal has resistance. But in your O levels, we ignore the resistance of wires. But actually, it may reduce some amount of electrical energy, right? Because he's making journey from point A to C, which needs some energy, right? So he's going to basically lose some energy here, which was gained by the battery. Imagine you're just moving over here. Okay, you're moving in a desert here, right? Just keep relating the story here. And then let's say you hit a bump here, right? So this is a lamp here, ठीक है, which is going to need some energy. Let's say you're going to hike a mountain here now, ठीक है. Let's say from point B in this journey of desert, you basically want to now climb a mountain here, right? Want to climb a mountain here. Let me just fix it here, right? So now this is, let's say you, I want to climb a mountain here, right? So obviously this would basically consume more of your energy, and you basically need more water to drink over here, right? So imagine this case, it has to cross this lamp here, right? This lamp is a sort of a lossy component which will consume energy, right? And it will basically be causing some potential difference here, because what is potential difference? It is the work done required to move a unit charge across the component here, right? So there will come potential difference over here when this particular Mr. Coulomb makes a journey from here till here, right? And you can see that his bag, his magical bag of electrical energy, reduces shrinks to a very smaller value, right? Because he lost a major chunk by basically making his journey from point C to B, right? So this lamp basically consumed a lot of energy, which converted into light energy plus heat energy in the surrounding, right? So now the Mr. Coulomb is at point D, right? And again, he has some enough some energy such that he can basically make a journey from point D to point E, and his bag is now literally empty here. You can see that it has no electrical energy left over here. Surprisingly, Mr. Coulomb sees the life-saving source again. He enters the battery again, and the battery does what? It fills his bag of electrical energy, and he basically the battery pushes Mr. Coulomb to make another trip, right? So this is how basically the current is flowing across the circuit here, right? So these are this bundle of electrical energy basically are charges, right? The charges are flowing across the circuit over here. Okay, I hope it makes sense. If you have any queries, please pause the video and watch it again. Okay. This is a very interesting story which is built up over here. I believe now it makes sense कि how are the energy moving over here? What is the role of a battery in a circuit, and what is the role of a component, like resistor, lamp, anything else apart from battery? What do they do, right? So they consume energy, right? Okay, so now we know the story here. So we have learned the story of 4.2.17 also. Okay, if you increase the EMF, if you have a large wattage of bulb, you want to produce more energy, more brightness, and also more heat energy, right? So this is just discussion over here with what we have seen here. Let's see what are they saying here. So the figure 4.2.17, which we learned about this was this over here. Two lamps or different power ratings, right? So it shows that the greater the EMF was applied, the larger the bundle of energy given to each coulomb, and greater is the rate at which energy is transferred from a lamp, right? So they are saying okay, if you have greater, let's say, voltage of the battery, the bag of Mr. Coulomb will be basically huge, right? It will be basically huge as compared to this battery source, right? Imagine, let's say, you're getting an ETH on your ETH. Okay, let's say you get 2K from here, let's say from your Ali Bhai, and you get basically, let's say, 200 from Haris Bhai, right? So again, just imagine, right, how much you can buy from these money, right? So this is, just imagine this now as basically charges over here, right? So the amount of charges which they can provide and fill the bag of Mr. Coulomb is defined by their EMF. So the greater the EMF, the greater the bundle of the bag, size of the bag, and greater it will basically be greater the energy which will provide to the components, right? Uh, Now we have the formula which links everything together. So work done is the energy transferred, take care, when charge moves around a complete circuit, right? So the EMF of the battery is given by this. We have seen this formula before. That EMF of a battery is basically work done required to move a unit charge across the complete loop of a circuit, right? So if you want to find work done from here, just make word a subject. So you get the following equation over here, right? So if you want to find the work done that is done by the battery to move the entire charge throughout the complete circuit, okay? And if you know the charge value also, you can easily find it out, okay? Now we have the SI units over here. First of all, let's talk about the SI units. The SI unit for the charge is basically for charge is basically coulomb, right? And for energy is basically joule, right? So what is going to be the work done unit over here? Is it going to be joule or is it going to be something else? You can think about this over here. Okay. So since we're talking about work done here, right? So work done का ऐसा यूनिट हमारे पास क्या होता है? It's equivalent to energy. That is, it is same as joules here, right? Right. So work done and energy are equivalent over here. So work done is again. If you recall formula of work done is basically force into distance. From the forces chapter over here, this is Newton meter here, which is also equivalent to joules here, right? So it's same as it is over here, right? So if you just work down the formula for charges, that is what is charge over here? Charge is basically current into time, right? And what is energy here, right? We can just basically energy is basically what over here? Energy is work done upon charges, and you can also find energy using the idea of EMF, right? So this is also measured in joules. So you can figure it out over here, combine them together, and get the same relation over here, right? So the assignment for work done is joules here. Okay, so I guess I made a slight mistake here. So E is basically EMF over here, right? Right, it's the volts here, right? It's the volts here. So I messed it up with the energy here, right? So EMF is basically, so work done is basically going to be coulombs into volts, right? And if you can think about the volt definition here, what was volt? It was force upon charge, right? Right? And if you can just figure it out, combine them together, so you get the same relation which you basically found as above. Okay. That is going to be Newton meter here, right? If you break it up further away. So that is going to end up leading towards basically joules over here, right? Okay. I hope it makes sense, right? So just for your ease, the unit for the word done is going to be energy, that is joule, right? ठीक that is joules, capital G. If a question, you can just pause and you watch it again. If you still have doubts, you can just send it to WhatsApp. Okay. Now we are gonna find a formula for in different forms, right? Now I'm gonna find a formula for word done, right? In terms of what? In terms of current flow in the circuit, time it takes to complete the round, right? And the voltage of the battery, right? Right. We already had this formula right now with ourselves, that is E equals to a charge into EMF over here, right? So let's find the word done over here. Okay, so now we are talking about a component here, right? So we have a battery here. Let me just make a battery made up of cells. So we have a battery here, right? And then we have a let's see, this is a resistor here, right? So the current flowing through circuit is I, and let's say this is point A, this is point B, right? And it takes basically T seconds to pass through A to B, and the voltage, the potential difference across this resistor, we have basically measured is using voltmeter here, coming on to BV, right? So if I just basically write down the formula for work done, so this is basically simply charges into voltage, right? E is EMF, right? यहाँ पे EMF is basically not used. यहाँ पे we will use volt potential difference over here, right? That is V. And if you recall your last lecture, what is charge? Charge is basically current into time over here. So we have two equations right now. That is equation one is this, the equation number two is this. So we substitute equation two into one, right? Let's see what do we get. Therefore, the work done can be found out using the formula which is I into T into the potential difference across the component, right? This is basically the end of formula. This is shown, right? So this is how you basically solve it out, right? I hope it makes sense. Okay, these are not so difficult over here. They should just make you should always visualize the concept, right? Just imagine a circuit and how is it working together, right? Connect the bits and the dots. So now let's basically do a practice question here, right? So I want you to pause the video here and solve the question. As soon as you're done, then you can play the video again, right? So let's solve it out together, right? First of all, I hope you're done with the course solution. So what is the circuitry here? So a lamp is connected to a battery in a circuit and a current flows. The simple circuit, right? So you have a battery here, right? And then you have a lamp here, all right? And when the connection is complete, the current flows. Okay, the battery has voltage V, current has this is lamp here, right? And then current is from over here, right? So once you have the circuitry ready, it basically makes it very simple to understand the question. So if the potential difference across the lamp is 6 joules, okay, and the charge is flowing through the circuit is basically 2 coulomb. You want to find out the potential difference, okay, at which the lamp is at, right? So the formula which we have discovered in the last slide is basically following, right? The work done is basically charge into potential difference, right? So work done is equals to charge into potential difference. This gives you 1 mark, right? Now just put in the values to get the answer. The work done by the sort of charge to move across the lamp is 6 joules, and the charge that is moving through the lamp is 2 coulomb. The potential difference is unknown here, right? So can we make a weak subject over here that is going to be 6.2. It lead towards basically 3, right? 3 volt is the potential difference across this lamp here, right? That is the answer. Okay. Now we have a part B for this, so you can basically take a screenshot of this, and then I wanted to pause the video here again, solve it out, right? This is the part B of the previous question. We have the same circuit, right? Now the quantity is given to us are changed, right? So now they're saying that the potential difference of the lamp is now 5 volt. We want to find the energy transferred to the lamp when the current is flowing of 2 amps in 5 seconds. Okay? So we have the same circuitry here. We have the battery and we have the lamp here, right? We have the lamp here, we have the battery here, and we are using a voltmeter. We'll see what is this in a while. Okay, don't worry. We have a voltmeter to measure the voltage. Potential difference across the volt lamp is that is VL is 5 volt. The current flowing through the circuit is basically 2 amps, and it is flowing for how many seconds? For 5 seconds. We want to find out the total energy that is supplied by the battery to the lamp. Okay? So if you can make the diagram, that is fine. If you can just write down the data as given, okay, what is given to you, that is also fine, right? So okay, you are given the voltage here, 5 volt. You're given the current here, that is 2 amps. Given the time here, that is 5 seconds. Want to find out what? Want to find out the energy transfer, that is the burden over here, right? So the formula over here, which we decided derived in the last slide, that is work done is current in time into volt potential difference here, right? So that is going to be VIT. That is the short form to learn this formula. Okay, just put in the values and get an answer. So it's 5 into 2 into 5. So it's 5 has 25, 25 to is 50 joules. This is the work done that the energy, this is the amount of energy that the battery has transferred to the lamp to glow and produce heat energy in the surroundings. Right? So I hope it makes sense. Okay, they are not so difficult concepts here. So these are interesting concepts, right? So just imagine the battery is pushing the charge to move around and it basically tackling the resistance of lamp. We'll see what is resistance in the next slide. So it has a phenomena which basically resists current. It leads towards losses, right? Think about you are running in a park and in front of you you basically see a huge flock of group, say a huge flock of people, right? So let's say you're running at a very fast rate when you're crossing the flock of group people over there, you slow down, right? You might basically collide with some person, okay? You might basically get stumbled. So you're losing energy over there, right? So you want to move across the flock of people over there that basically makes you consume more energy, right? Just imagine that lamp or resistor as those quantities, right? They try to slow down the the flow of current, right? and in doing so, the energy is getting lost. Okay. Now coming to the next measuring instrument device, which you have seen on the video, that is the voltmeter here, right? How do you connect them? What is the symbol for voltmeter first of all? Let's start with that. The symbol for voltmeter is basically this, right? And what does it do? It basically measures EMF and potential difference across components, right? EMF is for batteries or cells, right? And potential difference is basically for all other components, right? Let's see what is a voltmeter formally now. So voltmeter is used to measure potential differences, right? It should always be placed in parallel with the component across which the potential difference is to be measured, right? The positive terminal on the voltmeter should be connected with the positive side, okay, on which the current is flowing, okay? And a simple moving coil voltmeter will read DC voltages only on analog display over here, right? So this is saying okay, if we have a simple, let's say, analog version of the meter, which is basically using a single coil. This is a very simple form of voltmeter here. So we will learn this in detail. Okay, how do they measure it out? Okay. So this is an analog voltmeter which is shown on the bottom of your screen. Again, why is it analog? It is not showing digits here, right? It basically goes from here till here, right? And it gives you the value of the reading. You can see that the max value here is 10, right? You can measure up to 10 sorry, 10 volts here, right? Let's see the schematic of the circuit here, right? Okay, how do we attach it in the circuit? Okay, so let's say again we have a battery here, right? And then we have let's say a resistor here. It's very thick resistor over here. The resistor is basically just had seri, right? So it's very healthy right now. This is the lamp here, right? And this is the complete connection here, right? So the battery, the resistor, and the lamp here, right? Let's say if I want to find out, okay, how many volts are consumed by the resistor here. So I'll connect the voltmeter in parallel with this resistor here, right? So this basically does what you can see here. As a voltmeter has always two legs, okay? This is the voltmeter here. One leg will be positive, right? And the other leg would be basically mean negative here, right? So the red side goes towards the positive terminal of the battery, right? And this one goes towards the other side, right? So this is positive, this is negative. So what does voltmeter does? Okay. Let's say this is a battery of 10 volts. So at this point, I will be having 10 volts here, right? Because we are assuming these are wires. So we are assuming कि in wires we have no loss. जो potential हमारे पास यहाँ पे था बैटरी का, that is plus 10 volts, that is going to be same as here, right? Let's say as it crossed the resistor here, it lost some voltage, right? And the voltage is now, let's say, 7 volts, right? So what is the voltage that is dropped across the resistor? Is 3 volt, right? You can see that uh, through the diagram also. But how does the voltmeter figures it out? It basically differentiates, right? It finds the difference of the voltage. So यहाँ पे इसका जो voltage आ रहा होगा वो VA होगा. यहाँ पे जो voltage ये basically measure कर रहा है, it is VB, right? So voltmeter does what? It basically subtracts VA from VB. Sorry, it subtracts VB from VA, right? So it does this difference over here. Okay, you can see that VA was 10 volt and VB is basically 7 volt here. So how many volts are getting dropped across the resistor? That is 3 volt here, right? So this is the potential difference across the resistor here. So this is saying that resistor consuming 3 volts of energy, 3 volts of basically uh sort of volts, which were sent to Mr. Coulomb to move across the circuit, right? And we will basically see the next steps. How do we figure out the formulas to find out the unknown voltages? Okay. So now I'm not going to go into detail, Abhi Dada. So just understand this case. How is it happening, right? How does it work, right? So I believe that now you are well aware about voltmeter and how does it work and what does it measures, right? So let's do a test question over here just to see that how much you understood, right? So for this, I'm going to ask you to request you to pause the video and then solve the question. Okay. So I believe that now you are done with the question. So let's start solving it out. You have an analog version of the voltmeter. Okay. And this is shown in figure 4.2.20, that is here, right? So what are the two ranges available on the voltmeter, right? You want to see it over here, right? So yes, just these are saying okay, from basically you can see you have two scales here, right? The first scale is at the top and the second scale is at the bottom here, right? So this is just asking okay, what are the ranges available for measuring of the voltage, right? So how many set of combinations you can use to measure voltage here, depending upon the scale, right? So you can see okay, the first one is basically the top one can measure up to 0 to 10 volts, right? And the bottom scale, if you use the bottom scale over here, it can measure from 0 to 5 volts, right? So these are the two ranges available on this voltmeter here, right? 0 to 10 and 0 to 5 volts. Right? These question comes in exam, MCQ, right? So make sure to know this. Okay, so now they're just basically testing your reading skills here, right? Part B, you can just again pause the video and solve it out and then compare the answers. They're saying okay, what is the smallest division between number 3 and 4, right? For that, I'm going to basically copy this and bring it here. And I'm going to crop this further. Okay, I just want to zoom in into the voltmeter scale. Okay, so let's zoom in here. So you can see okay, 3 and 4 are the bottom ones, right? They're saying okay, what is the smallest division that is shown here, right? So you can just count the number of lines. There's 1, 2, 3, 4, 5. So it has 10 divisions between 3 and 4. Right? So these basically represents the points, right? So if we have 1 divided by 10, so each small digit shows 0.1 volt difference here, right? So they represent what? They represent basically a smallest value of 0.1 volt. That means you can have values from 3.0 to 3.1 all along till 4.0, right? Okay, so which scale would you choose to measure a voltage of 4.6, right? So if you want to be very accurate in your readings, which scale you want to use? You can see that in the bottom scale, I can get readings up to 0.1, 0.5, 0.6. Therefore, I'll be using the bottom scale here, right? Because it has 10 divisions. You can see the top one. The top has 2 unit difference here, right? So if you want to find the smallest division here, for the top one is going to be 2 upon 10. That is going to be 0.2. So let's say this is 6. This is going to be 6.2. This is going to be 7, right? So you cannot represent 4.6 here, right? You want to be very accurate over here. So you should basically use the bottom one. Okay? That will show you accurate scale reading over here, right? So bottom scale should be used here. Okay, so when the voltmeter reads 4.0, where should you position your eye to measure the readings? Okay, so let's say when your voltmeter is at here, right? And you want to measure it physically with your eye. Let's imagine that this is your voltmeter here, right? This is showing 4 here, right? So your eye should be such placed in such a way that it is perpendicular with the scale here, right? To avoid what? Parallax error, right? So this should be answer here for part D. Right, this question is very experimental, so it basically contributes to the ATP exam, right? P4 component here, not P4, it's P5 for you guys. ठीक है, एक मिनट होगा, P1 P2 P3 P4, you do P1 P2 P4, हाँ it's P4 for you guys, ठीक है, P5 मैंने मिक्स कर दिया 11 का. अच्छा जी, now interesting part here, right? So if you are, let's say, restless, you can take a pause, right? Pause the video here, ठीक है, and then take 2 3 deep breaths and then start restart the, not restart, unpause the video. Okay. Now I'm gonna talk about resistance here, right? Why is basically what is resistance? I'm gonna visualize it through some experiments, some visualistic, realistic scenarios. And we'll see okay, what do they do in a circuit, right? Okay. I'm gonna cover till basically here today. Okay. So we can cover the remaining in the next class. Because you cannot cover so much content in just one go. Okay. So I'm gonna give you a patient break after this. Okay. So again, I told you a story before this. That was, imagine this. You have two scenarios, right? Scenario A, scenario B. Okay. This is a simple flat road. Let's say this is Hamza running. Okay. Hamza running on the track here. This is smooth, right? Hamza can go freely. Okay. Now imagine okay, this Hamza is walking on another day, right? But now there's a huge group of people here, right? Take it over, right? And I can just make this sort of as a resistor here, right? This is R. So this Hamza can be a charge, right? A charge in a circuit, right? So now when he moves here, it moves freely till here. Now he basically when he wants to move from across this R, he would basically be need to push some people away, right? And he needs to basically he might get stumble with two people, right? He need to push them away, he need to make some room, take care. In doing so, obviously Hamza's muscles are working out and he basically loses some energy here, right? When he exits here, Hamza, right? So he loses some energy. Let's say the energy of Hamza was, let's say I'm going to talk about the volts. It was 7 volts here. So when he came out and he basically started to continue to run here, it came out to be, let's say, 5 volts. So he lost basically 2 volts to move across the crowd here. This is the role of a resistor here. Okay, when the current is basically flowing, it tries to resist the change in current, right? So it resists current here. Okay, just like air resistance. Imagine you're moving in air, moving in a car. Okay, so your air is basically trying to stop you down, right? Imagine this. Now, similarly, if in a circuit the current is flowing, right? The resistance trying to stop it down, slow it down, right? So sometimes resistors are useful, okay? Sometimes they are not useful, right? So obviously everything is pros and cons, okay? Let's now try to basically understand this formally, right? So electrons move through more easily through some conductors than others when a potential difference is applied. The opposition of conductor to current is called resistance, right? So in a circuit, when you have a circuit here, right, this component is, is called a resistor, right? Symbol for resistor is this, right? And it does what? It opposes the flow of current, right? So a good conductor has low resistance because it easily allows the current to flow. Obviously, a poor conductor or insulator has high resistance, right? Because it does not allow the current to flow. Okay. I hope it makes sense now. Okay. So 4.2.23 is basically the symbol over here, which you need to see, right? This is the part of a circuit shown here. And this is current flowing into the resistor here. It is shown by the symbol here. And there is some potential difference drop across this that is shown by V here, right? To learn this formula, you basically have a trick to learn it like this. Okay, you have pyramid here, right? And the quantity which are side by side, they multiply. The quantity which are basically up and down, they divide, right? So let's say if you want to find voltage, that is going to be current into resistance, right? If you want to find, let's say, current, if you have resistance and voltage, you can find it basically as follows. Okay, since you can see that voltage and resistance are up and down, they're going to be dividing over here. If you want to find resistance, it's going to be basically V over I, right? We will see this formula. What is this formula here, right? We'll see the formula in a while. ये होता क्या है? So these are the different forms. You can just learn this pyramid over here to derive the formula, right? So this is basically used to find resistance. How do you find resistance? You can find resistance by using this formula, right? If you know the potential difference across the component, if you know the current passes through the component, you can easily find out the resistance of the component here, right? This is the formula here which relates the resistance, potential difference, and current flow to the circuit. Right. So yeah, now I believe here you have an idea what is resistance. It tries to stop the motion of current, and it's just the opposite quantity over here, just like friction, right? When you're moving, friction is trying to oppose the motion, right? Similarly, when the current is flowing, resistance is sort of the blocking component here, right? So now you know the quantities and concepts over here. So I want you to solve this question here, right? Pause the video and then solve the question. So always, I believe that you are now done with the question. So you have a potential difference of 4.5 applied across the lamp, right? Current flowing through the lamp is 1.5 amperes. You want to find the resistance of the lamp, right? Obviously, lamp has also resistance, right? So you have a scenario which is this. So you have a lamp here, right? And the current is flowing through the lamp, that is I, and I is equals to basically 1.5 amps. And you're using a voltmeter to measure the voltage that is getting dropped across the lamp here, right? And this lamp is already obviously glowing over here, right? Lamp is made up of wires, and if there are wires, it has resistance, right? So you want to find the resistance that is offered by the lamp here, right? So you can just make a diagram to simplify your working, or you can write down the data given to you, right? So what is given to you? You're given the potential difference that is across the lamp. You're given the current that is flowing across the lamp. That is 1.5 amps, right? You want to find what? You want to find the resistance, right? So what is the formula for resistance? Just recall the pyramid here, right? What is the pyramid? It was this, right? It is V I R. How do you find R? R is basically what? V over I, right? This is the formula over here. So R equals to V over I. So let's put in the values to get the answer. So it's going to be 4.5 divided by 1.5. So the resistance that is offered by the lamp is 3 ohms. Okay, simple, right? It's not so difficult. If you try to, if you understand it and you can visualize the concepts, it's going to be very interesting. Okay, in the next chapter also. Okay, okay. Let's move on. Now, given something else, we have the same scenario, okay, which we established in the last slide. Pause the video and basically solve the question here, right? We have current, okay, that is 0.5 amps flowing. You know the resistance of the lamp. Okay, in this scenario, that is 5 ohms. If you let's say you want to find out the potential difference across the lamp here. Okay, let's you cannot use a voltmeter here now. You need to use the formula, right? So again, recall the pyramid. I believe that now you're done with the question. Okay, solve कर लिया आप लोगों ने. So the formula pyramid is as follows. So how can you find potential difference? The potential difference is basically I into R. So just put in the values now. It's 0.5 into 5. So that is going to give you an answer of 2.5, right? 2.5 volts. So the drop across the lamp is now 2.5 volts. I believe your answer is matching it. Okay? Your questions, please rewatch the last part. Okay. Okay. So now I'm gonna move on towards resistors here and their construction, their symbol, right? So conductors intended to have resistance are called resistors, right? So if you want to design, basically resistors are made up of wires, right? So the way we design them is basically defines if it is going to be a resistor or not, right? So they are basically made from wires or special alloys or from carbon, right? So this is the symbol over here for resistor, electrical symbol. This is the physical device which is basically used in labs and industries. And this is a variable resistor over here, right? We will see what is a variable resistor over here. You can just see a knob here, right? This is a knob here. So obviously, when you just recall your, let's say in your homes, you might have a controller of your fans, right? Or used to have in old times, right? Let's say you can rotate the knob and it reduces the speed of the fan, right? So imagine this, it's a variable resistor here, right? We control the amount of resistance that is offered by the resistor here, right? These are called fixed resistor, right? These are called fixed resistor. Why? Let's say if this resistor is of 5 kilo ohms, so it's going to be offering 5 kilo ohms continuously throughout its life, right? So those used in radio and television sets have values from few ohms to million of ohms, right? So just saying, okay, these are the set of range of resistors which is available in the industry, right? Right. Now I'm going to just introduce over here about variable resistor. We're gonna continue and dive deeper into it in the next class, okay, which is inshallah Sunday, right? So let's just introduce here what is a variable resistance, right? So just think about the term here. So you have variable and resistance. You know what is resistance, right? It is opposition to current, right? And variable means ke it can basically fluctuate, right? Between some range of values. Let's say from A to B, right? So variable resistors are used in electronics and then there are called potentiometers. Okay? Because we can basically have volume, they basically are used as volume or the controls here, right? I will give you examples in the next class, inshallah. Okay, where do you find this in practical, in your physical scenarios, right? In your real life scenarios here. So variable resistors take larger currents like the one shown in figure 4.2.5. You can see that this is a construction of a physical potentiometer here. So you have two terminal here. Okay. The three terminals here. Terminal one is here, terminal two is here, the three is here. So one and three are basically contain a fixed coil here. The terminal two is basically sliding, right? It slides, it moves back and forth, right? So the point it is touching basically can change the amount of resistance. Let's say it is touching over here. So we'll have a different resistance value over here, right? So you can slide over this entire fixed rod over here. Okay, this is the construction part over here, right? So again, the point at which it is at contact, okay, this part decides the value of resistance of the potentiometer, right? Till then, let me just quickly give you a summary here. So resistance is basically what? It is the opposition, right? It is opposition to current flow. So variable means here you can fluctuate the value, right? So variable resistance is basically the phenomenon in which you can control the amount of resistance, right? They use in electronics. Basically, I gave an example of fan. You might have seen in older days, we had fans, and we had a control knob, right? If we move the control knob clockwise, the speed of the fan reduced. If we basically moved it anti-clockwise, it increased the speed, right? So if we have used or seen those potential knobs of fans, give me a thumbs up. Okay, Hamza ने देखा है वो, right? So yeah, these are basically called potentiometers here, right? Okay. So now this is the construction over here. So now we have how can I create variable resistor here, right? That is the question. Okay. So I know okay, now what is variable resistance, what is a variable, what is a potentiometer here, but how can I create this? Okay. That is as follows. First of all, I'm gonna explain the theory and then we see the diagrams. Okay, what do they mean? So we can create it in two ways. Okay, we can create it using two ways. Okay, it is glitching here. This is here, this is here. Okay, we can create this basically using two ways. Okay, and the first is called a rheostat, right? You can change the current in a circuit. Only one connection and the sliding contact are then required over here, right? So moving the slide contact to the left reduces the resistance, increases the current here, right? The 4.2.26, right? This is a rheostat here. Okay, rheostat is basically again a variable resistor. So if you move it on the left, okay, you can see that what happens. Basically moving the left reduces the resistance here, right? So if you move it left, the resistance basically, let's say the max resistance it can offer over here if my contact is here. Okay. Let's say it can offer the maximum resistance of 5 kilo ohm, right? And the minimum resistance, let's say if the slider is over here, the resistance becomes basically 50 ohms, right? So we have a range of resistance which it can basically provide, that is 50 ohms to 5 kilo ohms, right? That is how the rheostat works, right? And then we have a potential difference, potential divider here. Okay, can create a variable resistance, can also add a potential divider or change the potential difference across the device, right? Again, what happens over here? We have moving knob here, right? This is basically a moving knob here. So depending upon the position of the knob, it basically changes the resistance. It's again, it is 5 ohms here and 5 kilo ohm here, right? So it can basically also change the resistance, and we will see that how do they basically, how does it affect the potential difference here, right? So this is the circuitry of this particular application, and the symbol for variable resistor is this, right? It is just a resistor symbol with an arrow on it, right? Arrow shows you can vary the resistance, right? So this is the electrical symbol over here. Okay. So if it makes sense till now, give me a thumbs up. Okay, it makes sense to Maeve. It makes sense to Hamza. What about others? मशाल को भी समझ आ रहा है, that's good. It's not so difficult, right? It's just visualizing it, right? Varda, it's clear? Okay, let me check the comments here. Okay, no comment. It's clear. ठीक है, that's good. Okay. So, ठीक है. Now we have this scenario here. Now, we basically made some assumptions here, right? So, in a circuit, अगर आपको मैंने लेक्चर देखा है, तो उसमें I talked about कि the resistance of wires is ignored, right? Wires are made up of basically metals, right? Conductors. So उसकी भी resistance actually होनी चाहिए वैसे, ठीक है? But for simplicity, for calculations and no levels, we basically ignore the resistance of wires, ठीक है? Now when I understand कि let's say if I have a metal, ठीक है, a metal rod, right? Let's say if I have a metal rod, how does the resistance of the metal rod would vary depending upon its dimensions, right? So I have this, right? I have a metal rod here. Okay, I have a metal rod here. Let's say this is copper, right? And this is the cross-sectional area of the metal, and this is the length of the metal, right? So we have some relations over here which can basically, now also since it is a metal here, right? It will also offer some resistance, right? And it offers the resistance R, right? So now I want to find some relations which link the relation of R and cross-sectional area. Okay, how does resistance changes depending upon area, right? I also need to figure out okay, how does my resistance changes depending upon the length of the conductor here, right? ठीक है. So let's see what happens over here. So this is the relation which is basically the rule that resistance of the metallic wire increases as you increase the length. ठीक है? It increases as you reduce the area, right? It also depends upon the type of material, obviously, right? If it is a insulator, ठीक है, plastic है, तो resistance बहुत ज़्यादा होगी, right? There will be no conduction, right? ठीक है? So now, what is the relation which is configured over here, which we find out that resistance is directly proportional to length, right? And resistance is inversely proportional to area, right? It makes sense, right? It should make sense. Okay, if you have longer wires, obviously they would have more material over there, more number of atoms. Therefore, the resistance will increase, right? If you have smaller area, you have less number of atoms. Therefore, resistance should decrease, right? This is a relation of okay, if you increase the length, the resistance increases. If you increase the area, right, the resistance decreases over here. Sorry, I said the inverse over here. If you have more area, right, and the same number of atoms, right, it will reduce more spaces, right, and therefore it will basically produce less resistance. Okay. So the compact the area it is, there will be less spaces between the atoms, right, and it will be difficult for the charges electrons to move through, right. So if these two relations make sense, give me a thumbs up. Okay, it makes sense to Maeve, makes sense to Mashal or the Hamza. Clear है? Hamza, I believe clear होगा. ठीक है. Let's read the remaining theory here. A long thin wire has more resistance than a short thick one, right? Of the same material. Silver is the best conductor. That is why you might have seen in Karachi, K Electric has replaced all the copper wires with silver, right? But copper is the next best, is cheaper. ठीक है. Do you remember in Pakistan, in Karachi, basically all the wires were made up of copper first, right? Now they have been replaced by silver, right? And some people are saying, yeah, they are selling copper over here. That is not true, right? Silver has become the international standard over here, right? Silver has become the international standard throughout the world, right? So now all metal wires, ठीक है, all conducting wires are made up of silver now. Why? Because copper is basically used in coils, right? They're using coils, ठीक है, which are basically found in motors, ठीक है, and they are found in generators, right? So we are producing cars multiple daily, ठीक है, multiple amount of time in a day, right? So we need copper there, and copper is basically a rare element, right? So for saving this particular element, we have converted all the wires into silver, right? That is the reason, okay, the silver have been replacing copper in Karachi, right? अच्छा जी. Now let's go on. The resistance of a metallic wire is directly proportional to its length and inversely proportional to its cross-sectional area. This is a summary here, right? Achari, so now if I want to write down a summary here, right, before starting this, uh, let me just write the summary first. So let's say you have two copper, two copper rods, okay, same material but different dimensions, right? It has area one, cross-sectional area one. It has the length one, okay, and they both are made up of copper. They're made up of copper here. This has area two, and this has length two, right? So let's write down the equations over here. And it offers resistance 1, it offers resistance 2, right? Let's relate the resistance 1 and 2, right? So R1 is proportional to L1, right? And over here R2 is proportional to L2, right? Since the material is same, okay, if I basically introduce a constant here, it should be some constant K here, right? Right? And similarly, if I do this over here, if I remove the sign of proportionality, I would have a constant introduced K. Since the material is same, this K would be same for both of them, right? So I'm not going to introduce what is K right now. So K has a specific name, okay? So if I basically equate these two K's over here, so I have the following relation over here. That R1 upon L1 is equals to R2 upon L2, right? So this can be a question in your exams, and this will be tested right now on your next slide. Okay, if you let's say if you have L1 given to you, if you have R1 given to you, if I just give you the length 2 of the other rod over here, you can find the resistance it would offer, okay, which was unknown over here using this relation here, right? So if it makes sense, give me a thumbs up. This relation between resistance and length makes sense to me. If Hamza, okay, Vardha, that's good. ठीक है, मशाल पसंद आ गया, ठीक है. Mama catch up and watch the recordings basically for the session missed, right? Now let's link the areas, cross-sectional areas and the resistance, right? Let's link that now. Okay. So I'm going to basically duplicate the slide here and erase this part here. Okay. Now I have a relation that R1 is inversely proportional to area 1, right? And R2 is inversely proportional to area 2 here. Again, if I remove the sign of proportionality, I will have this constant, right? This constant K here, right? And again, if I remove sign of proportionality here, I will have constant K here, right? So again, I can equate these two K's here to basically get my relation. This is R1, sorry, A1. R1 A1 is equals to R2 A2, right? Again, if you have any unknown over here, you can find out the unknown by just using this equation over here, right? Okay. I hope it makes sense right now. Okay. Up the last relation which I want to explain to you, that is as follows. Okay. Let me insert a slide here. Again, now you have a conductor here. Here the cross-sectional area here, and this is the length here, right? So we had derived just two relations between resistance, right? And it offers resistance R. So resistance proportional to length over here. This is first relation, and then resistance is inversely proportional to area, right? This is the second relation over here. So can I combine this together in a single equation? I can, right? So I combine these two equations as follows. The resistance is proportional to length and inversely proportional to area, right? It satisfies both the formulas. Okay, it is directly proportional to length and is inversely proportional to area. How? If I increase the area, you can see that resistance would decrease. If I increase the length, it would increase the resistance here, right? Okay. So this is the combined relation also over here, right? So just know this relation also, right? Okay, let me just see. Okay, do you have 1 kilometer? Okay, resistivity. nahi hai. Okay, so let me just tell you over here for just your understanding, right? So if I basically want to remove the sign of proportionality here, right? I have to introduce a constant here, right? Okay, so let's do that. So resistance is proportional to length over area. I want to remove the sign of proportionality. I need to introduce a constant, and that constant is basically called rho, right? This constant is called rho over here. Okay, this symbol is called rho, right? It basically represents resistivity, right? Just for your understanding over here, okay? So this is the final formula for resistance, which links the length, area, and this resistivity basically depends upon type of material, right? Copper will have different resistivity, okay? And silver will have a different resistivity value, right? And copper, iron would have different resistivity value, right? And this is the final equation, which is basically combining all the relations of a conductor, right? Dimensions, types, length, and so on and so forth, right? So if it makes sense till now, give me a thumbs up. Okay, it makes sense to Hamza. Okay, that's good, everyone. So okay. Now we have again a summary here. Okay. So experiments show that the distance r of a y is proportional to length, okay, and inversely proportional to area, right? Acha, I just want to basically now tell you in terms of radius and diameter here, right? So since the cross section of a y is always a circle, right? If you place the eye over here, okay, you will see a circle here, right? So you will see if you just basically fix this view here, you will see a circle here, right? And circle has a radius r. Want to find the area of a circle, that is going to be pi r square, right? But if you are given a diameter over here, how do you find the area? So basically diameter radius is basically 2 times d, right? And diameter is r upon 2, right? So if I want to replace r by the diameter, right? So I can do it by this, okay? Okay, मैंने उल्टा कर दिया basically. So your radius is d upon 2 basically. The diameter is 2 times r. Okay, if you multiply the radius twice, you get diameter. Want to find a radius, that is the half of the diameter, right? So just substitute this equation into this to get the equation in terms of diameter, right? This is going to be pi into d upon 2 whole square. So your area in terms of diameter of a circle is pi d square upon 4. You might have seen this in mathematics, right? Not so difficult. Okay. So now let me just tell you a relation here. Okay, let's say Acha, not this. I want to insert a blank slide. Let's say if I say K Hamza, this is the actual basically copper rod here, which has a diameter D. Right, the diameter of this rod is D, right? Which has a cross section area, let's say A, which is pi D square upon 4, right? If I now basically reduce the area, ठीक है, if I basically make the new diameter to be half. So what effect would it have on the resistance, right? इसमें इसका half किया है, it is not going to be so small, right? इसको मैंने half कर दिया, right? Diameter को. So the diameter is now d upon 2. So now let's find the change that it would have on the area, ठीक है? The new area here. So area bar is going to be, ठीक है, pi d square upon 4, right? My new diameter is basically now half d upon 2, right? So let's substitute the value here. It's going to be pi upon 4 times d upon 2 whole square, right? So let's see what happens over here. We have pi d square upon 4, ठीक है, times 1 upon 4, right? ठीक है. So let's equate these two equations here, right? So we have A equals to A bar. I want to find the effect of area now, ठीक है. So let's see this. Or I can do basically what? I can basically divide A bar upon A, right? I'm going to divide A bar divided by A. So it's going to be pi d square upon 4 into 4 divided by pi d square upon 4. So obviously this will reciprocate. This will convert to multiplier sign, and I would basically reciprocate this. This becomes A bar upon A equals to pi d square upon 4 into 4 times 4 upon pi d square. So this cancels out, this cancels out. So you have the following relation now. That is A bar equals to 1 upon 4 A, right? Right. The new area is basically now reduced by 1/4 of the actual area, right? So now what effect does it have on the resistance that you want to see, right? So let's see that. We have seen that resistance is inversely proportional to area. Okay. My area has now reduced by 1/4. So if I reduce my area by 1/4, it is now 1/4 of A, right? So this would increase my resistance by 4 times. Okay. Okay. Does that make sense? It's just simple calculation here, right? If it makes sense, give me a thumbs up. Okay, it makes sense to me. Hamza, Mashal. Okay. Varda, clear है? It's just simple mathematics. Okay, I'm just dividing it. Okay, if it is not clear, let me know. I will repeat. Okay, I have a comment here. Okay, it's clear. That's good. Right. Now since I have done detailed analysis of resistance and area and length over here, you have a question to solve, right? Just to solve this question, you have 3 minutes to solve the question, right? So I'm going to write on the formulas here. Okay. That resistance is proportional to length, resistance is inversely proportional to area, right? And from this you have R1 upon R2, sorry, R1 upon L1 equals to R2 upon L2. Okay, and then from here you had the equation that is R1 A1 equals to R2 A2. Okay, now solve the question here. Okay, जी guys, I hope that you all are done with this question. So let's start solving it out. Okay. It's a similar question which we have created a scenario for in the last slide, right? So कह रहा है कि आपके पास you have a wire, copper wire, right? It has a diameter of 0.5 millimeters and a length of 1 kilometer. And at this particular dimension, it offers a resistance of 84 ohms, right? Now they're saying that you have the resistance, okay, of the same, you have a wire of the same material. You want to find the resistance if it has the length of 500 meters, right? Okay. It has the same diameter and same material. Only the thing which I changed is the length here, right? So I need to apply this relation here, right? Okay. So this is very simple over here. It's going to be R1 upon L1 equals to R2 upon L2, right? So resistance 1 offered at 1 kilometer. So 1 kilometer is 1000 meters, right? Yeah. And the R2 is unknown. The length 2 is 500 meters. Just solve it out. Just basically send this over there. It's going to multiply, right? So let's see what do we have here. If I simplify this further, I will have R2 equals to 84 times 500, right? So this is 500 ones are 500 twos are 2 ones are 242s are, right? So resistance 2 is basically now 42 ohms. It makes sense, right? It should make sense. Okay, if you decrease the length, the resistance should decrease since the relation is proportional, right? It is proportional to each other over here. So if you basically half the length, the resistance should also be half, right? Okay, that is what happened over here. If you got the same answer, give me a thumbs up. Okay, Hamza got the same answer. Masha got the same answer. That's good. What about Acha? What got the same answer? Maeve? Okay, if you haven't got the same answer, kindly just cross check your mistake. Okay. Now it has a part B here, which is basically now talking about the it is now varying both of the things here, right? Not the both of the things. The length is same, right? You can see length अभी इसकी यहाँ पे 1 kilometer है and over here is also 1 kilometer here, right? The length is same. Now he's varying the diameter here, right? Now they want to find the resistance at this particular diameter, right? So for you need to relate now areas here, right? So what is the relation of resistance and areas? It is R1 times A1 equals to R2 times A2, right? So we need to first of all find out the area when the diameter was initially 0.5 millimeter, right? So you want to convert this millimeter into meter first. Okay. So your D1 is given to you as 0.5 millimeter. Okay. Which is going to be 0.5 into exponent minus 3 meters, right? And your new diameter is basically what? It is 1 millimeter. That is 1 exponent minus 3 meters, right? So let's find the area 1, area 2 first, right? Area 1 in terms of diameter is going to be pi d square upon 4. We just learned the formula, right? Let's put in the values here. Pi d1 square. That's going to be pi into 0.5 exponent minus 3 whole square divided by 4. Get me the answer for this, Chilli sir. What is the answer for A1 coming out to be in terms of meter square? And then I have area 2, which is going to be pi d2 square upon 4, right? Let's just put the values over here. It's going to be 1 exponent minus 3 whole square divided by 4. So what is the answer for this also coming out to be? Should be in meter square. चलिए से बताएं. I don't have my calculator right now. What is the answer coming out to be for A1 and A2? Quickly, anyone? Check 1, 2, 3. Okay, I'm waiting. I am waiting here. So, Mushal, what is the answer it is coming out to be for area 1? Or Varda or Maeve? Am I audible? Hello? Check 1, 2, 3. Okay, Varda आंसर बताएं जल्दी से फिर. Okay, so let me do the mathematics in my head. Okay, since I believe you don't have a calculator at your ends also. Okay. So anyone who has got the values till now? No one. क्या हो गया भाई? मशाल and May, don't you have calculator at your end right now? Hello, guys. Am I audible? Chale bhai, let me just now figure it out. Okay. So it's going to be 5 by 4. Okay, why the things are audible, but I don't want to solve the answer, right? Okay. So yeah, 0.5 exponent minus 3 whole square. So for this, I'm getting 1.9635 exponent minus 7. So it's 1.9635 exponent minus 7. TKD. And for the next one, I would have 7.854. 7.854 exponent minus 7. Okay, now let's relate the two things here. 7.85. तो बता क्यों नहीं दिया पहले वर्दा? I was waiting for you. Okay. ठीक है. Let's now finish up the answer here quickly. Okay, it's my keyboard. Okay. Now we have the relation over here that is R1 times A1 equals to R2 times A2. R1 we know that it is 84 ohms offered by the original material here, right? So it's 84 times A1, that is 1.9635 exponent minus 7. And R2 is unknown. Okay, which you want to find out over here. Okay, and the area 2 is coming out to be 7.854. 7.854 exponent minus 7. Right? So let's just solve it out for R2 here. Okay, so what should be the answer? So if I now do this, 84 times 1.9635 exponent minus 7 on answer. So it's going to be 21 ohms, right? It's coming out to be 21 ohms. Okay, the ohms. 20.97. Yeah, that's good, right? Achari, so I forgot one thing to cover here. That is the SI unit of resistance. मैं cover किया था? Let me go back. Go back, go back, go back, go back here. Okay, resistance. So basically the SI unit for resistance is ohms, right? Let me write it down over here. The SI unit for resistance is ohms, right? Ohms. It has this symbol here, right? Ohms, right? Just remember this. This is called capital omega. It's a Greek symbol. ठीक है? अच्छा जी. Now I believe it is clear now. Let's proceed to some graphs here, right? I'm going to give this as a homework assignment over here, right? So it's not so difficult here, right? So I'm just going to explain this in sort of summary here कि what graphs do we have here, right? So ohmic conductor क्या होता है हमारे पास? Ohmic conductor is just a normal wire which you have. You can just imagine a copper rod here, right? And we have established the Ohm's law that voltage is proportional to current, right? If I remove the sign of proportionality, I get the Ohm's law, right? V equals to IR, right? So this Ohm's law is basically followed by only ohmic conductors, right? That basically follows the this relation. Okay, current is going to be directly proportionally with the voltage here, right? Ohmic conductor. You can see that it's a direct relation. It goes a straight line passing through origin, right? So all the wires, okay, all the conductors which basically can allow electricity to pass through, they're called ohmic conductors over here, right? Then we have a diode here, ठीक है? Diode symbol हमारे पास ये होता है. This is a diode here, right? So diode is basically in a circuit क्या करता है ये? If you have a battery here, right? Imagine that it is sort of a blockage here, right? It only allows the current to pass through in this direction, right? So if you let's say flip the polarity, if you place it like this, okay, let's say like this, right? Since we follow the conventional current flow, so it will block the current here, right? So this side basically blocks the current, right? If your current is entering this side over here, it is going to block the current, right? And you can see that in negative direction of the basically current, the voltage is almost zero, right? Right? So it's not allowing the current to pass through over here, right? And if you have, let's say, in this particular case over here, this is basically allowing the current to pass through, and this is a non-linear graph, right? It's a non-linear graph over here. It is saying that it does not follow Ohm's law, right? So we need to learn about this over here, right? So होता है क्या हमारे पास? The resistance of the diode decreases as the current increases, right? Therefore, you have this increasing curve over here, right? And then you have filament lamp, right? You might have seen this in your old days when we had filament lamp, right? This is the filament lamp which I'm talking about over here. Okay, this is the filament lamp which I'm talking about over here. So what happens in this case, if you basically increase the current in this, so its resistance would increase, right? Because it gets heated up, right? That leads to this long non-linear trend over here, right? Okay, so this is again non-ohmic conductor. It does not follow Ohm's law, right? And then you have thermistor here. Thermistor symbol हमारे पास ये होता है, right? This is thermistor here, right? So उसमें होता है क्या हमारे पास? It's a sensor here. So if you increase the temperature, the resistance drops, right? So it's inverse relation here, right? So if you increase the temperature, the resistance drops here, right? And you can see that it's again a non-linear trend. It basically is a decreasing graph here. And if you increase the current, the resistance basically what is happening over here, it basically follows a non-linear trend here, right? As you can see, the resistance over here is decreasing, right? This is R2, let's say this is R1, right? So if you want to find R2 is going to be 1 over slope, right? What is slope of this graph? What is slope of this graph? Is going to be I over V, right? Delta I over delta V. And if you check the Ohm's law is as follows, that P equals to IR. You want to find R, that is going to be delta V over delta I, right? So over here you have the inverse scenario here. So to match the formula, you want to take the inverse of the slope, right? So greater the slope, smaller the value, ठीक है? तो यहाँ पे R2 की वैल्यू छोटी होती आ रही है, ठीक है? R1 बड़ा है, ठीक है, R2 से. So you can see that as the temperature is increasing, the resistance is dropping over here, right? Does that make sense? If it makes sense, give me a thumbs up. Just small summaries here, right? These are not so important in your syllabus. Yeah, you should know okay, huh? This is the theory which you know over here. Okay, these are the graphs, these are ohmic, and these are non-ohmic conductor over here. Ohmic क्या होता है हमारे पास? It follows the Ohm's law. That is, you have a straight line passing through origin, right? अच्छा जी. So can you explain what is power? What is power? Yes. Any guess? Give me a guess. What do you understand about power over here?
So we can like define power as the rate of doing work where work is in joules.
Yeah, that's good, right? So it's same as the power phenomena concept which we have learned in the forces, right? In Verdun. Okay. So in if you recall your last chapters, the dynamics chapter, right? So if you imagine, okay, let's say we are applying a force here, a distance. We're basically applying. Let me just fix it to force. We are applying a force, and this box moves at distance d in the same direction. Let's say it moves from A to B, okay, in a time of t seconds, right? So we learned this in the previous chapters, that power is equals to energy upon time, right? And how can you find energy? Energy is equivalent to work done, right? So if you can find work done, that is force into distance, is same as energy, right? So we learned that if you want to find power, it is just the rate of exchange of energy, right? So power is simply work done upon time, right? So यहाँ पे we are basically applying a physical force on an object over here, right? Now just imagine this concept in a circuit way, right? On a circuit over here. Let's say you have a battery. You have a battery here, and then you have a resistor here. Right? This is plus minus 10 volts, right? And this is a resistor of 10 ohms, right? And the current is flowing in this direction from positive to negative, right? And if just imagine a charge, right? Just imagine a charge plus Q, let's say, right? It is moving throughout the circuit, right? It travels a certain distance, right? It travels a certain distance, okay, per unit time, right? So similar concept can be applied over here. Okay, the power is basically work done by the battery to move a positive charge around the circuit in a certain amount of time, right? This is power definition over here. If it makes sense, give me a thumbs up. It's pretty simple, right? So something is pushing the charge around the circuit, right? So that is the battery here. So in a certain amount of time when the charge moves, so there is some power that is basically provided by the battery over here, right? That is basically electrical power here, right? So this is the same definition here in written over here, that power is the work done upon time taken or the energy transferred by the battery to the charges in a certain amount of time, right? Uh, so it is important to learn the rate at which the electric current transfers energy from the source to the circuit components. So if you recall the topic 1.7.4, that was the forces chapter over here, that was dynamics. So we learned, okay, we can derive this using this formula, which basically gave us this relation over here, right? And if I want to find out the units here, so if you recall that power is equals to work done upon time, right? So power is measured in watts, right? And the work done is basically measured in joules, right? And the time was basically measured in seconds over here. So we also learned that 1 watt was basically equals to 1 joule in 1 second, right? So we have learned these principles here. So now let's see, okay, how do we basically convert this relation which we derived in the chapter of forces into a formula which is basically containing electrical quantities. Like, let's say if you have a circuit over here, you have a current flowing through the circuit, right? You have a certain potential difference drop across this, right? Let's say the VR, right? And take some time to for the charge to move around the circuit over. So the electrical quantities are basically voltage V, the current I, and the T time, right? So how can I convert this formula into a relation that is basically containing only electrical quantities, right? So that is as follows here, right? So if you recall this, uh, can you let me just go step by step. So if we have, let's say, power is equals to work done upon time, right? We have this relation here from the chapter number forces, right? Right. So can you tell me relation of work done in terms of charges? What is the formula of work done in terms of charges? Any guess? Just see this relation here if you can derive any relation which moves into your head. Basically, what was potential difference? What was potential difference which we have learned in the last class? The potential difference was the work done per unit charge, right? So if I want to find work done, if I want to make work done subject over here, I can send Q over here. So it becomes V into Q, right? So this is one equation here, that is equation A, right? So now, if you recall the formula of current, what was current? Basically, current is the rate of flow of charges, right? So how can I basically make Q subject over here? I can send T there, right? So Q is basically I into T, right? So I have this second equation here, right? So I can substitute B equation into A equation. Therefore, I get that work done is equals to voltage into current into time, right? So I have this equation of work done containing only the electrical quantities here, right? So this is equation number C. right? And this is equation number, let's say 1, right? So now again substitute what? I can substitute equation C into 1, right? So let's see what do we get. So power is equals to, in terms of burden, I'll substitute equation number C, that is V into I into T divided by T, right? So this T and T cancels out. Therefore, if we want to find power in an electrical circuit, that is simply equals to the potential difference across that particular component, right? Times the current flowing in the circuit. Okay, so power is equals to VI over here, right? And the unit for this is thus shown over here. The unit for power is again same, that is watt, right? Watts, capital W, right? So now if you also want to define watt in terms of electrical quantities over here, that is going to be as follows, right? You know, okay, we have this formula here, power is to VI, right? And V is measured in volts, right? Current is measured in amps, right? So now in electrical domain, okay, 1 watt is basically same as 1 volt, 1 volt times 1 ampere, right? Right. So if you want to define this in terms of words, so 1 watt is the power, consumed by a component when there is a potential difference of 1 volt with a current of 1 ampere flow, right? So that's how you define this formally in terms of definition, right? So that should give you the 1 mark definition answer over here, right? So if the relation, if the derivation of power and the assignment makes sense, give me a thumbs up. Okay, it makes sense to Mama. That's good. Okay, that's good, right? So now this is everything what is written over here. That power is basically this VI. We had derived this relation over here. And energy is basically VIT, right? We also derived this relation over here in the last slide. That work done was same as energy is equals to VIT, right? So we can learn this formula also over here, right? This is formula number, I can say, let's say formula number 2, okay? And this is formula number 3, okay? If you want to learn, right? Now it is just basically, let's do an example here, right? So you have a lamp, right? You have a battery source that is giving you a voltage E, right? You have an ammeter here which is measuring the current flowing over the circuit, okay? I, and I is this, right? And this is I flowing through the circuit over here. This is plus negative, and I place the voltmeter in parallel to measure the voltage drop across the lamp, right? This is basically measuring voltage of lamp, right? So what is the question given to you over here? So if a lamp has supply of 240 volts and it has a current of 0.25 amps, right? So how can I find the power that it is consuming over here, right? So the lamp is basically having a 240 volt supply, right? If you can imagine over here, this is supplying 240 volts here, right? So this complete voltage is basically getting consumed at the lamp, right? So V lamp is also same as 240 volts, right? And I know the current flowing through a circuit, that is I is equals to 0.25 amps. So I can find the power that is consumed by the lamp, that is V into I. So the power is going to be basically just 240 times 25 upon 100, that is 0.25, right? So this gives me an answer of what? This go cancel out. Let's say 5 2s are 5 5s are 2 1s are 2 12s are 12 are 60, okay, 60 watt. So this basically lamp is consuming a power of 60 watt from the power supply over here, right? So that is the answer over here, okay? Does that make sense? If yes, thumbs up. Okay, it makes sense to Hamza. That's good. It's simple, right? It's not so complicated. Does that make sense, Mama? Oh, okay, that's good, right? So now we have learned the basic formula for power, that is VI, but it can have also other forms, other different forms of formula, right? So how? If you recall, we have learned the Ohm's law, right? What is the Ohm's law here? Ohm's law stated as follows, that voltage of a the voltage proportional to current here, right? So if I want to remove the sign proportionality, I introduce a constant that is R over here, right? Resistance. So this is the Ohm's law here, right? This is the Ohm's law here. And if I want to plot this graph plot this equation on a graph, that is going to be as follows. If you have I over here, if you have V over here, so it's going to be a straight line passing through origin, right? And this is stating that V is proportional to I, and the slope of this graph, define the slope of this graph, right? And this M is going to give you basically what? V over I, okay? And that is equal to the resistance, right? This is the Ohm's law here, okay? Now we also have derived a equation for power in terms of voltage and current, right? Imagine कि आपके पास circuit है as follows. You have a power supply, you have a resistor here, and then this is going to the negative terminal here, negative, positive. This is basically providing voltage V, right? And this is basically carrying a current of I, right? I and R, right? So now you want to basically find out, okay, you can find out the power directly from just multiplying the current and the voltage VI. But what if in the question, basically you don't know the voltage, okay? You know the current and the resistance. Can you find out the power that is consumed by the component? That the answer is yes, right? So let's see how. So now we have two equations at our end. Okay. So the first one which we have is power equals to VI. And the second one, which is the Ohm's law, is basically as follows. V equals to I. Okay. So now let's substitute. Let me just label them. This is equation number 2. And let's see this equation number alpha. Right. So let me substitute now alpha equation into equation number 2. Right. So in place of V, I'm going to substitute this relation for it. Okay. So let's see what do we get. Right. So we have power is equals to something times I. Right? And that something is the Ohm's law, V equals to IR. So therefore, I also have one relation to find out power, that is I square R, right? So if I don't know the potential difference across the resistor here, if I just know the current and the resistance value, I can still find out the power that is consumed by the component here, right? Using the formula that is I square R. So this is my another form of the formula of power, right? So we had this first form. This is the second form over here. I'm going to label it as 2 bar, right? This is the second form of the power here, right? Now let's find the third form over here, right? I can also basically make current subject over here. This would be V over R, right? So now this is equation number, let's say beta. This is equation number beta here, right? So now I can do what? I can substitute equation beta into equation number 2, right? Let's see what do we get. So now we have, in place of I, I'm going to substitute this relation here, right? So we're going to have V into V over R, right? Therefore, the next equation which we have at our end to find power is V square upon R, right? So what is it saying? This is the third form of finding power. So in the circuit, now if you don't know the current passing through the resistor, if you know the volt potential difference across this, TKV, so and you know the resistance of the resistor over here, still you can find out the power that is getting dropped across the circuit using the formula. The power is basically the voltage potential difference across the resistor squared upon the resistance value, right? So these are the three states of finding power, three state of formulas which you can use to find power across a component, right? If it makes sense, give me a thumbs up. These are very important questions, right? If the derivation makes sense, give me a thumbs up. It makes sense to ma'am. That's good. Okay, it's simple, right? So you should know derivation. They might ask you to derive the equations, right? So you should know this. Now, since you know the equations here, there's a small question for you guys to solve, right? So let me draw the circuit here. So you have the battery, let's just cell here, and then you have a resistance, right? Okay. You know also the current flowing through the circuit. This is I, this is V, right? The I is given to you as 0.5 amps, right? And the resistance value is 12 ohms, right? You want to find the potential difference across the lamp. right? So formula which you basically have derived now is basically V equals to IR. You know this, you know the power formula, that is VI. You know to how to find power in terms of only current and resistance, that is I square R. You also find power using voltage and the resistance also over here, right? So these are the formulas over here. I'm gonna give you 2 minutes to solve it out. Okay. Find out the potential difference across the resistor here, that is VR, right? 2 minutes. Okay, Ji, so let's do it out. So it's pretty simple. I hope that you're done. So you can simply apply this formula here. That is the Ohm's law formula, right? You want to find out the potential difference across the lamp here. So you're going to simply V equals to IR. So you know the current pass through the lamp, right? The resistor. So you can basically remember modeling the lamp as a resistor here, right? It has a resistance of 12 ohms, you know, current flowing through the lamp, that is 0.5 ohms. Therefore, the potential difference drop across the lamp is going to be 0.5 into 12 ohms, right? So the potential difference across this, the lamp is 6 volts here, right? That is the answer. Okay. Let's do part B. What is the power of the lamp, right? So up, you can find out power using different formulas. Okay. Up, what do you have over here right now? You have the scenario as follows. So you have a battery here. You have a lamp, right? Okay. And you know the resistance of the lamp also. That was basically R equals to 12 ohms, right? You know the current also, right? That is 0.5 amperes flowing through the circuit, right? And now you know also the potential difference across the lamp, that is 6 volts, VL, right? So you can find out power using all the formula which we have learned, okay? The 3 formulas. So I'm going to use all of the formulas here to show the answer same आएगा, okay? So power equals to VI, the first formula which you have learned. So you know the potential difference across the lamp, that is 6. The current flowing through the basically lamp is 0.5. So the power consumed by the lamp is 3 watts, right? So let's use the second formula, that is power equals to I square R. Okay. You also know the current flowing through the circuit, that is 0.5 ampere square times 12. That is also going to give you 3 watts here. Okay. You can check it out. And then the third formula which you have learned, that power goes to V square upon R. Okay. You know that V is 6 square upon 12, right? It's 36 upon 12. It is same now again, 3 watts, right? So if you use any formula, but you should know कि आपने formula सही से इस्तेमाल करा है. It should give you the same answer over here, right? That is the beauty of basically these set of relations here, right? It can converge to a same answer. You can have different approaches, but the answer should be same, right? Achari. So this is part B. So now the part C is saying okay, how much energy is the lamp consuming in a time of 6 seconds, right? So now you know the power, right? You can find out using 2 approaches here, right? You can just use this formula that power equals to energy upon time, right? If you know this, you can find out directly basically energy, because आपको भी power पता है from the last part, you know the time also, right? So you will have this following relation over here, that energy equals to power into time. So it's going to be 3 into 6, right? That is going to be 18 joules. So 18 joule consumed by the lamp here, right? Or you can use the formula of energy, that is energy equals to what? VIT, right? So voltage drop across the lamp is 6 volts. The current is 0.5 amps. The time taken is 6 volts. Okay. So 6 into 6 is 36. 36 and a half is 18 joules. Again, the answer is same. Okay. I hope it makes sense, right? If it makes sense, give me a thumbs up. Okay, it makes sense to ma'am. Look at this. These are typical exam type questions, right? So you should know how to solve them out. Hamza, clear? Hamza, are you here? ओके नाउ द इंटरेस्टिंग पार्ट, जो आपके पास घर पे बिल आता है वो कैसे आता है, राइट? Obviously you have some appliances in your house. You have bulbs, you have fans, you have refrigerator, microwave ovens, right? Kettles, so on and so forth, right? So how does your electricity bill is computed over here, right? So you might have seen your electricity bill. So it basically comes as follows over here, right? It comes in kilowatt hour, right? So kilowatt hour is basically 1 unit, right? ठीक है. सो 1 किलोवाट आवर you see your electricity bill, तो आपके पास आता है यूनिट, राइट? Let's say this is 1 unit over here. So 1 kilowatt hour of energy once you are consumed is basically 1 unit, that is going to be shown on your electricity meter here, right? How do you find this? Right. So let's see it out first of all. What is the theory here? So electricity supply companies charge for the amount of energy they supply, right? A joule is a very small amount of energy, right? If you recall, 1 joule is basically 1.6 exponent minus 19 coulombs, right? Okay, if you recall the formula of work done, okay, that is voltage into charge, right? So if you have 1 volt of charge, if you have 1 coulomb of charge, right, that is going to basically give you this much, right? So 1 coulomb contains actually 1.6 per minus 19 electrons, right? So let me just skip it now. आप confused ना हो रहे हैं. So let's now go simply, ठीक है, to the relation here, right? So joules को measure करना is very small amount and it does not give you accurate results here. That is why they basically measure in kilowatt hour. So if you see the formula here, the energy is equals to power energy upon time. So energy is going to be power into time, right? So you can see that you have the unit as follows. That is watt into, basically if your power is in watt, if your time is in hours, so you already get here it's watt into hour, right? So energy comes out to be watt into hour, right? So but they are measuring watt over here, they're measuring kilowatt hour, right? Okay. So if you have 1000 watt hour, that is going to be a 1 unit in your bill, right? How do they compute this? How many joules it converts to? It is as follows, right? So if you have, let's say, if your energy is consumed as 1 kilowatt in 1 hour, so how much energy is your appliance using? How many joules is your appliance basically consuming? It is as follows. ठीक है? अभी कैसे निकाला हम लोगों ने? So we have basically energy is equals to 1000 into basically 1 hour is how many seconds? It is 3600 seconds, right? So time is 3600. That is going to give you answer in joules, right? So this energy is equals to basically 3.6 megajoules. So if your appliance basically consume 3.6 megajoules, it is going to be a 1 unit in your electricity bill, right? This is a conversion ratio over here. A 1 kilowatt hour is 3.6 megajoules of energy, which your appliance basically consumes in 1 hour, right? Achari, this is some rough values of some different appliances, how much power basically they consume, right? What is the power rating here? So let's say if you want to find out the current, okay, that is consumed by the cooker here. So you can see the rating of the cooker. Okay, it has a power rating of 6.4 kilowatt, and you know the formula for power, that is VI, right? You know कि आपके पास जो इलेक्ट्रिसिटी आती है फ्रॉम द के इलेक्ट्रिक और एनी पावर सप्लाई कंपनी gives you 230 volts, right? So you can find out the current that is going to be transferring through the cooker here, right? That is going to be power upon voltage is going to be 6.4 kilowatt divided by the voltage that is getting supplied to your house, right? So it comes out to be 28 amps, right? Okay. So that is why this is just saying that this is a too large current over here. So we need to have some separate circuit over here. You might have seen कि आपके पास different rooms के अंदर you had different basically connections from your main power board, right? एक रूम की सप्लाई अलग ब्रेकर से कंटिन्यू कंट्रोल हो रही होती है. इफ यू सी अ इलेक्ट्रिसिटी बॉक्स एंड यू हैड डिफरेंट रूम्स बेसिकली गेटिंग ऑपरेटेड बाय डिफरेंट कनेक्शन, राइट? एंड हर कनेक्शन के अंदर भी है ब्रेकर्स, ताकि वी कैन बेसिकली डिवाइड द करंट हियर, ठीक है, टू बेसिकली हैव से ऑपरेशन ऑफ इलेक्ट्रिसिटी ओवर हियर, राइट? दिस इज जस्ट एग्जांपल हियर कि व्हाई डू वी हैव डिफरेंट कनेक्शन फॉर डिफरेंट appliances, ठीक है, because they had different current ratings, which basically if you fix everything to a single line, it will consume huge amount of current. It might burn the line, right? Because the greater the current, greater the flow of electron, greater the heat energy dissipation, right? Therefore, greater chances for getting a fire started, right? So now let's solve this question, and this would basically end our chapter here. This is just an example here. Okay, the price of 1 unit of electricity consuming is 10 cents, right? So if you have a 3000 watt electric heater in your house and you operate it for 3 hours, how much will you be charged, right, from the power company? So it's pretty simple. Let's find out the total units, okay, which you are consuming over here. Okay, so we simply multiply the power, right, into hours, right? So you want the units to be in kilowatt hour, right? ठीक है. So for this is going to be 9,000 watt hour, right? So you can convert this into kilo as follows: that total units which you're consuming by this particular, which you consume by the heater, is basically 9 kilowatt hour, right? So since one unit is 1 kilowatt hour, so you're consuming basically how many units here? If you see,
9 kilowatt hour.
yeah, so one unit is basically 1 kilowatt hour. So if you have 9 kilowatt hour of energy consumed, how many units are this? You can cross multiply this. The X is coming out to be 9 units, right? So if you have this scenario, okay, the 1 unit price which is charged by the company is 10 cents, right? So if you have consuming 9 units, ठीक है, gonna have how many charge? X cents, ठीक है, cross multiply. It's gonna, you have to pay basically 90 cents for consuming 9 units of electricity if you use the heater for 3 hours, right? If it makes sense, give me a thumbs up quickly.